good career? If so, is it challenging or unchallenging?
It's certainly challenging because just of the nature of the subject, there is quite a lot of maths and quite a lot of physics.
Hello, guys. Hello. Can you all hear me?
Good evening, sir.
Yeah. Good evening. Good evening, guys. Can you all switch on the cameras if you don't mind? We have Vasundra, Anaya, Yasodini, and Januti. Yeah. Okay. All right. Okay. Okay. Perfect. Okay. Okay, so before we start today, right, I just want to ask you all a few questions. Okay, so just to get to know your model much better. Okay, so in order to make stuff easier, when I call out your name, you just have to tell me like, hello, can you hear me? Am I audible? Am I clear? Is my voice clear on your side? Nivan, can you hear me? All right, okay. Okay, perfect. So before we start off, I want you all to introduce yourself, and to make stuff easier, when I call out your name, you just tell me your name, which school you go to, what class you are in, and why are you interested in astronomy? Why do you want to learn astronomy? Okay, right. So first we have Nivan. So Nivan, can you introduce yourself?
So, my name is Devan and I'm 7 years old. I'm in the school of Wingham College and I'm in grade 5. And the reason I'm interested to join the astronomy camp is because all the interesting stuff in space.
All right, okay. Thank you for that, Nivan. So next we have Anaya.
Hi, I'm Anaya. I am 9 years old. I learn in Life and International School, Bachelor. I'm interested in astronomy as I like to learn about planets and stars.
Okay, perfect. So both Nivan and Anaya, like they want to, explore more about space. They want to especially learn about planets and stars, which is really awesome because those topics will be covered, in large extents in our astronomy camp. So you guys don't have to worry because everything will be covered. So that's nice to hear. So we'll move on to the next student. So that's Januki. Hello. Hello, Januki. Can you hear me? Hello. Januki, are you there? Hello, Januki.
My name is Cynthia.
Yeah.
I go to East International School.
Okay.
I'm 7 years old.
All right. Can you tell us, like, why are you interested in astronomy? Why do you want to learn astronomy?
I like star.
All right. Okay. Okay. That's great. Okay. So we have 3 star levels, right? So we'll be learning about stars as well. So yeah. So that's nice to hear. We'll move on to the next student. So that's Yasodini.
I'm Yashodini. I'm going to Sangamita Girl College in Kirindiwala. I'm 12 years old. I like to search about planets. That's why I learn astronomy.
All right, super. Okay, thank you. Next we have Dimit.
My name is Dimit and I'm 7 years old. I go to Ananda College.
Okay. And why do you, like astronomy? What do you love about astronomy? What do you want to learn?
I love to learn about stars.
All right, okay. So the majority of the answers that I got were basically to learn about stars, right? So not only about stars, we'll be learning about many other things as well, right? Things that you guys, I suppose you guys wouldn't have even heard of. So we'll be covering everything, right? From A to Z. So when you talk about stars, there's so many things that are there to be covered, like how a star is formed, what's inside a star, and why is a star shining, right? Why is it huge? And different types of stars in the universe, and so many things. And how does a star how the formation of the star, as well as the death of a star. Why does a star die, and how does it die, and what happens after it dies? All these questions will be covered, right? Everything will be done thoroughly, so you guys don't have to worry. And I'm really happy that you all are in the right place, right? So um, any questions that you all have, and every single thing will be covered regarding to astronomy. All right, guys? Okay. Okay, then. So now that I have, you guys have introduced yourself, and I have some idea about you guys, and your liking towards astronomy. Um, just want to mention few things. Is that Yeah, I just want to mention a few things before we proceed with today's introduction. Is that, during this astronomy camp, if you have gone through the videos in social media, because we post, our classes on social media platforms like Facebook, YouTube. So if you go through the videos, you can see most of the students, right? So students just like you, who are in our astronomy camp, are, very much how can I word it? Like, they are very interactive. They talk right during the class. Like, it doesn't mean that they disturb the class. They do not disturb. It's like, when I ask question, they unmute and they ask, so they answer. And plus, sometimes when they have questions, when they have curiosities, when they have certain doubt about a certain topic, so they don't feel shy. They do not keep it with themselves. They always unmute and ask questions. That's the same level of dedication that I want from you guys as well, right? So this is an astronomy camp. It's not like a traditional classroom, like what you have in school. So I'm not gonna teach stuff all about astronomy and you guys have to keep quiet. It's nothing like that. I'm really friendly and I want to see you guys speak as well, right? So even if you all think, okay, I'm gonna my question might sound very shallow. It might not be, very interesting. It might be very, it might be a stupid question. So you don't have to think that way, because all questions are valid here, right? In the astronomy camp. Sometimes you might even not, you might have a question about the sun, right? So you might ask a question like, what is the sun, sir? Is the sun a star? Well, it's a very basic question, but sometimes students, they might feel a bit hesitant to ask this question, right? So what I'm saying is that you don't have to feel hesitant. You don't have to feel shy. You can ask any question related to astronomy in this camp, and I want to make this camp interactive as possible, right? So 100% interactive. So 50% I will be speaking, and 50% you guys will be speaking, right? So once this interaction is done, if you all have time, you go to Facebook or YouTube and go through the recordings. Then there you can see like how interactive our sessions are. So the more interactive our sessions are, the more you get educated. Understood? I hope everyone understood that. Okay, you got it? That's perfect. Okay, so you all have to be totally free in the astronomy camp, right? So this is not going to be strict. It's a it's a very peaceful environment. It's a very fun environment. So that's what we're trying to create, and that's what we have created already. So we want you all also to be a part of this, okay? So that we can make this a success. So I believe that you guys will also be a part of this, and ask questions and quench your curiosity. So I really believe that you all do that. Okay. So now let me explain to you what astronomy is. Okay. So what is astronomy? So before I could explain, since you guys have not spoken much, I'll ask this question from you guys. Okay. Let's see who knows the answer. Okay. You can give your own view, your own thought about what it is. Okay. Even if it's wrong, no worries. What do you all think about astronomy? What is this astronomy? Right. So when you go to school, you have these certain subjects that you do, right? Like science, mathematics, geography, ICT. You know all about this because you all have been learning it. You all have been working with it. So there's no doubt about it. But what is this astronomy? What do you all think this astronomy is? Yes, Leah. Yeah.
What I personally think about astronomy is the things that are in space and things that are man-made, which are launched into space.
Okay. So Nivan gave us a really sharp answer, right? It was to the point. Thank you, Nivan. Anyone else want to share something else? Anything that they think about astronomy that you guys think about astronomy? Yes, Anna.
I think astronomy is learning about astronauts, stars, and everything in space.
Okay, super. Anyone else? Yasodini, Dime, Janaki? All right. Okay. So basically, astronomy is a study about the celestial bodies. All right. Anything that's beyond the atmosphere of planet Earth is considered to be a part of astronomy. It can be anything. It can be a galaxy. It can be our own solar system. It can be our neighboring planets like Mars, Jupiter, Uranus, Venus, Mercury. It can be about them. It can be about the meteoroids. It can be about the asteroids. It can be about the black holes, right? Anything that's beyond the atmosphere of planet Earth is considered to be astronomy. Okay, so astronomy is a vast subject, and under astronomy there are so many categories which specializations that people learn when they learn about astronomy. So I will tell you all what those specializations are later on in this astronomy camp. Hold on, let's just run down. Right. Okay. So later on in this astronomy camp, I'll tell you all what those specializations are. So basically, astronomy is nothing but study beyond the atmosphere of planet Earth. Anything that's in the celestial body, anything that is in the space, is a part of astronomy. Studying about that, right? So that's basically what astronomy is. So now, another very interesting question is that why do we have to learn astronomy? What's the purpose of learning it, right? Now, let me give you a good example. Now, when you go to school, you learn maths. Why do you learn maths? Because there's a reason to it, right? There's a purpose. Because if you don't know maths, it's very hard to survive in this world. Because everywhere you go, you need maths, right? And English. Why do you need English? Because if you travel anywhere, if you go work in an office, you need to communicate, and you need English for that. So now you might be wondering, why do I have to learn astronomy? What's the purpose? Well, there are a lot of purpose for astronomy. Okay, so now if you see 50 to 60 years back, no one learned a subject called computing, right? You can go ask this from your grandparents. Ask your grandparents if they learned computing at school. They wouldn't have learned it because back then it was not a big deal, right? It was not something that was very relevant in the society. No one had computers. No one, coded application. No one were programmers. There were very few programmers. It was not a big deal. But later on, when time passed off, and 20 years back, people started getting influenced by IC. People started, most of the people, they got computers, they got PDAs, they got mobile phones, and all these things started becoming famous. So now at this stage, without ICT, you cannot do anything. Even if you're going to a hospital, if you're going to, to a school, you're working in an office, wherever you go, it's all about computing, right? It's all about computing, coding, all those stuff. So now ICT is also now astronomy is also similar to that of ICT, right? So now it's gaining that popularity. So now if you see, I think you guys would have heard this news is that there's a billionaire, is a scientist called Elon Musk, right? So not only Elon Musk and also other people like Jeff Bezos and Bill Gates and Richard Branson. These people are investing a lot of money, like billions and billions and billions of dollars in space exploration. Okay, so they are creating spaceships. They are trying to expand space tourism, right? Because we have tourism, right? So when you go to India, you go to America, that's called as tourism. So now there's a new concept that's been, coming up. It's coming. It's called space tourism, traveling outside planet Earth, which is really cool. And plus, they are also planning of colonizing Mars, right? So you would have seen that Elon Musk is planning of colonizing Mars by the year 2024. So by 2030, hopefully humans will be able to go and settle in Mars. So now you see a pattern that people are more actively engaging in stuff that is beyond planet Earth. So in another 30 to 40 years time, right? So in another 30 to 40 years time, people who didn't learn, who didn't grasp this opportunity of learning astronomy will regret it badly because they will feel really bad. Trust me, they will, because astronomy will go to a very high extent that it will be demanded by everyone. Every industry will demand astronomy because it's gaining prominence, and the importance of learning the subject is growing day by day, right? So don't ever think that astronomy is just a subject. It is a very modernized subject. It's a subject which is gaining a lot of popularity, a lot of demand, and there's a lot of opportunities that are being created in the market for you guys. Okay, so if you're done with college, if you're done with school, and if you're planning of moving on to college, you can always pursue any career which is related to astronomy without being doubtful about it, because definitely there is a lot of opportunities for you guys. Even if it's not available in Sri Lanka, it's readily available outside this country. Okay, and even in Sri Lanka, it will probably be available in few years. Understood, Nivan, Ananya, Dimet, Yasodini, Januki, and Misal. All good?
Yes, sir.
Super. So now, do you all have any questions? Because I didn't see you guys, talk much. One thing that I highlighted is this has to be interactive. Yes, Nivan.
Excuse me, sir. How many percent of space was found?
Very good question, right? How many percent of space was found? Okay, so let me give you a rise, rather than jumping to the answer, Nivan, I'll give you a small example, okay, so that you will understand this even more better. Okay, let's say, let's take your home, okay, Nivan?
Yeah.
Let's take your house, okay, so you live in a house, right? So your house, I have no idea where you live, right? Do I know how many rooms are there in your house? I don't, right? Because I've never been to your house. I've never seen your house. I have no idea. I can only see the place where you are seated. So I know there's a bookshelf behind, and I know there's a brown color. I think it's a wooden chair that you're seated on, right? And I know there's a white color wall behind you. So this is the place that I can observe from my end. Understood, Diwan? So from my end, this is the portion of your house or your home that can be observed by me now, right now. Understood? So does that mean that, Nivan, that only this part, only this portion that is visible in your screen is your home? Is that the meaning? So don't you have any other partitions in your home, like kitchen, bathroom, garden, backyard, other rooms? Does that mean that you don't have any of those?
I have more.
You have more, right? But it's just that at this present moment, right now, I can only see this. So therefore, since I have no clue about what's beyond this area that is visible on the screen, I can never come to a conclusion saying, Nivan doesn't have a bathroom in his house, or Nivan doesn't have, two bedrooms in his house, or I can't say Nivan does not have three bedrooms in his house, or I can't say Nivan does not have a kitchen in his house. He might have two kitchens, he might have one kitchen, he might have three bedrooms, he might have two bedrooms, he might have three bathrooms, he might have two bathrooms, right? It can be anything. But for me, only this portion is visible. Now let's go on to space. Okay, so now when scientists have been observing, what they could see is something called the observable universe. So what does this observable universe mean? It is the only portion in the universe that is visible to us, mankind. So does that mean that anything beyond the observable universe is just void, is nothing? No, there's definitely something beyond that as well, right? But we are still not that technologically advanced in order to see what is beyond, right? So in the year 1990s, right, in the year 1990, when the Hubble telescope was launched, people were able to see vast distance. They were able to see, very long distance away from planet Earth, like millions and millions and billions and trillions of kilometers from planet Earth. And now, last year, when they launched the James Webb telescope, now the James Webb telescope is more capable and even more powerful to see what is even more beyond that. So if Hubble telescope could see 1 trillion kilometers away from planet Earth, James Webb telescope can see 10 kilometers away from planet, what Hubble telescope could see. So then people who lived in year 1990, what they had in mind is that, that was the observable universe and that's it. There's nothing beyond that. But people who are living now, like you and me, we know that that's not true. There is definitely something beyond that because we are able to see it. Now, do you understand, Nivan? So
Yeah.
there is no specific answer to how much percentage of space is fully discovered. But I can give you an answer is that it's very, 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 very less percentage. Like 0.000000001, even less than that percentage is being found.
That means they can only
Yeah.
see that means scientists can only see the galaxy. So
They can see the galaxy. Yeah, so we live in a galaxy called Milky Way galaxy. Okay, so now you just remember the name Milky Way because sometimes others might not know what Milky Way galaxy is. Don't worry, I will explain to you what it is in the astronomy. So now just remember that we live in a galaxy called Milky Way galaxy, right? So this Milky Way galaxy is visible to us, and the neighboring galaxies are also visible to us. But there are so many galaxies, right? There's not just 2 or 3 galaxies that are present in the universe. There are millions and billions of galaxies. So we could only see a handful of them, not a lot of them, not everything, not everyone can be seen, only a certain portion. So the galaxies that are, for example, let's say Nivan is planet Earth. Okay, Nivan, just imagine your planet Earth, and those books behind you are the galaxies. So so the bookshelf behind you, I can't see the entire bookshelf, right? So your bookshelf, I believe that it's huge, it's large, and there are many books that are not visible on the screen. So the books that are visible on the screen are the galaxies that we know of. The books that are on the other side of the shelf, which cannot be seen, are the other galaxies that we haven't still found or discovered. Understood? I believe all the other kids were also understood this question.
Yes, sir.
All right. So Nivan has been asking a lot of questions. He has been very interactive. Superb, Nivan. I want the same level of dedication throughout the astronomy. What about others? Even Tuan, he joined, right? So Tuan joined the last sessions as well. So he was also asking questions actively, which is really good. What about Anaya, Dimet, Yasodini, Januki? You guys also have to start speaking up. So seriously, do you all have any questions? Like if you all have any questions, you can always ask. Anaya, do you have any questions?
Not really, sir.
Not really? Okay. So you have to keep thinking, all right? So whatever I say, like certain things that you don't understand while I'm explaining, and you might be wondering, okay, what did sir just explain right now? It doesn't make any sense. So if you feel that way, if you feel hesitant, you can always unmute yourself and ask the question again, right? And again, like
it doesn't actually matter. Like even if you ask the question 1,000 times, I will not get irritated. Understood, guys? It's perfectly fine. So Dimet, what about you, Dimet? Okay. Yasodini? Hello. Hello, Yasodini. Got any questions?
Not yet, sir.
All right. Okay. So you see, guys. So the reason why in our astronomy camp we just we limit the number of students for 8 students, right? So we don't take students more than 8, right, in a batch. So maximum there are only 8 students in a batch. The reason why we do that is in order to focus more on you guys. Okay. So our session, the astronomy camp, we have one session per week. So a session is around 3 hours long. So it starts at 3 p.m. and finishes at 6 p.m. So the reason why it's 3 hours long is not because we are, explaining or we are teaching for 3 hours. We teach for like 2 hours, and that 1 hour is all about discussion. So I ask all the students. Now, for example, let's say there's student A, B, and C in my class, in my batch. I will make sure that student A is fully understood. He's aware of every single thing that we have been teaching in this class. And only then I move on to student B. And I'll do the same to student B. I will ask questions from him. And I will expect him also to ask questions from me, right? So whatever question that he has. And the same goes to student C as well. So this is like a family, right? So we are all discussing with each other. We are talking with each other. And in a way, astronomy is also a part of science, right? So what do scientists do? Do you think the scientists keep quiet and just do their work alone? No. If you observe how scientists work in day-to-day life, they always are in very productive discussions with each other. They talk to their fellow scientists. They share their ideas. They share their thoughts. And if they don't have any idea about a certain topic, they ask their colleagues about that and they clear it up. And the same thing the colleague does, right? So everyone does the same thing. They ask questions. They share their ideas. They share their thoughts. By doing so, they create a knowledge base. Understood? That's the same thing that we are trying to replicate here as well, right? So the more questions you ask, the more I answer your questions, the more we discuss, we can expand our knowledge, and we might even explore things that might not even be covered in the astronomy camp. Understood? So that's why everyone should actively ask questions and be very interactive. Anaya, you have raised your hand. Yes, you may speak.
Sir, how do people find astronomy as a subject?
Sorry, Anaya, I didn't hear your question. Can you repeat again?
How do people find astronomy is a subject?
Yes, astronomy is a subject. Even though astronomy is not a very popular subject in Sri Lanka, even though it's not taught in many schools, it is a subject that can be pursued by anyone, right? So anyone in the world, they can always pursue astronomy as a subject. It is readily available, and you have enough resources, you have enough documents, you have enough articles where you can start reading about it, you can start watching videos about it, and you can educate yourself always about astronomy. So you don't have to now think about how can I find articles, how can I find tutorials. You don't have to think about them right now, because you are in the right place, and you guys are actually blessed, because in this astronomy camp we will help you to do that. Okay. I hope I answered the question. Anaya?
Yes, I understand.
All right. Awesome. And then in the astronomy camp, right? So, we have, I think Nivan has participated, and also Nishar has also participated. You guys saw, right? So we get speakers from foreign countries, speakers who are, specialists in these kind of subjects like astronomy or paleontology. So last week, Sunday, we had Mr. Mason Wintermeister, right? So he's a specialized paleontologist who is a specialist on the study of dinosaurs and evolution. right? So he joined us and he gave us a really good lecture on how the dinosaurs went extinct, why it went extinct, and what happened after it went extinct. So he gave us a really good understanding about that. And also, when you joined today's class, you would have seen a talk show which was being played. So that was from astrophysicist Dr. Julian Onions, who joined us twice in our astronomy camp, right? And he also, there was a question and answer session where students were given the opportunity to ask questions directly from an astrophysicist, right? So an astrophysicist is basically a scientist, and he's from the University of Nottingham, based in UK. So students were given the opportunity to ask questions from him directly, any kind of questions that is related to astronomy. And tomorrow, luckily, it's a good opportunity for you guys as well. He'll be joining us again. So Dr. Julian Onions will be joining us tomorrow in our Sunday session. And he'll be talking about dark energy and dark matter. So if you guys have heard about it, or if you guys want to ask questions about it, this is the perfect opportunity for you all, right? So this astronomy camp is fully dedicated. It's we do our maximum to make sure that we cover every single aspect of astronomy. Understood, guys?
Yes,
All
sir.
right. Super, super. So now that we have talked a lot, and now that definitely you guys might feel a bit lousy and drowsy, So in order to shake things up, I have a really interesting video with me. So I'll show that video to you guys. Okay, so those who have a very limited idea of what space is and how space looks like and what are the things that we will be learning about, this video can clear a lot of questions. Okay, sometimes you might not understand certain things in this video, but that's all right. Okay, so I'll tell you what those are. So this video is it will just show you of the entire universe, like every single thing. So when I say the entire universe, it's basically entire thing that we'll be learning in astronomy. Everything it will be shown in that video. It's a very small video, very interesting. So hold on, sit back, and I hope you all will enjoy it. Just give me 1 second, I will play the video. Okay. Hello, Anaya. Is there any problem with the camera? Hello. Yeah, you can keep like if you have a stand, it would be better. But if you don't have a stand, you can stack books, and then you keep your phone. Or I think you're using a phone. Right?
No, I'm using a tablet. I'm finding this phone.
Okay, phone. So you stack books and keep your phone in front of it so that it doesn't shake or fall off. Okay. All right. Okay, now I think it's much better. And we can only see your forehead. That's the problem. Others I can see them clearly. Ivan, Dimit, Vishal, Yasodini. Now, okay, now it's fine. All right. Now it's visible. Okay, right. Hold on, let me show you. Is my screen visible, guys? Is it visible?
Yes,
Okay, now watch the video, all right? circle, all right? So from the surface of the earth, right? So now you guys are indoor. So just you walk outside and just, you don't look at the sun, but you just see how powerful the sun is, right? It's warming up the entire surface of planet Earth, and it's giving you all light, right? So the entire Sri Lanka is, lightened up by the sun's the lights that is emitted by the sun. So the sun is really huge, right? It's very powerful. But when you keep zooming out and when you compare it with the, the space that's around it, it's just, a speck of dust. Just look at it like with the neighboring stars. It's just a point. And now if you keep expanding it, you would see that it just basically disappears. So that's how insignificant, or that's how small or negligible we are when we compare us with space, right? So that's how huge space is, and that's how gigantic space is, and that's how gigantic the celestial bodies that are present in space can be, right? Compared to Earth, the sun, and the entire solar system. All right. Can you even pinpoint the sun? Can you show the sun where it is? No one can show it. But now it's like, it's disappeared. Like it's there, but it cannot be seen. So that's how much small we are. That's how much insignificant we are, when we compare with everything. And Nivan, a few minutes back, he was talking about the Milky Way galaxy. Remember? So I
Yeah.
told you all to just remember the name Milky Way galaxy. I will show you all what it is. So now you will see what Milky Way galaxy is. Right? So that's the galaxy where we are present in. That's the galaxy which the sun is located in. This massive spiral disk is what we call as the Milky Way galaxy, and it has so many stars that if you start counting the number of stars in this Milky Way galaxy, Nivan, how old are you?
9 years old.
9 years old. So Nivan, if you start counting the number of galaxies right now at this very second, by the time you reach the age 80 or 90, you will still be counting. Okay, so that's how much stars you have in this Milky Way galaxy, right? So that's why you could see that the Milky Way galaxy is white in color, right? It looks as if it's emitting light out of it. The reason why it looks like it's emitting light out of it is because it's filled with stars, tiny, 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 lot of stars. It's just filled with them. And when all the stars gives out light, you could see this, nice spiral galaxy called the Milky Way galaxy. Okay, and the and the time that it takes for the sun just to go around this spiral disk, or just to go around this Milky Way galaxy, how much do you think? Anaya, do you have any idea how long will it take for the sun to just go around this Milky Way galaxy?
200 million years.
Uh, Very good, Misha. 200 million years. Okay. So another question: how long does it take for the Earth to go around the sun?
1 year.
1 year, right? 1 year, or 365 days and 8 hours. That's how much time it takes for the Earth to go around the sun. No big deal, right? 1 year is not a big deal, right? So now we got the COVID-19 2 years back, and now 2 years have passed, and we can't even imagine how 2 years passed, right? It was so quick. But just imagine 200 million years. My God, that means, like, when the dinosaurs went extinct 65 million years ago. So even if the sun started rotating then, just imagine if the sun started rotating 65 million years ago when the dinosaurs went extinct, it still would be going around the Milky Way galaxy. It still wouldn't have finished one circle or one orbit around the Milky Way galaxy. Understood? So that's how cool it is. So every single thing. So I'm just giving you all an overview or basic introduction just to make this very interesting and to give you all a rough idea about what we will be learning. but every single thing will be covered in much detail. It will be all be really interesting. So that's why we have this astronomy camp. So it's 3 months long. The reason why it's 3 months long is we have a lot of topics that we are going to talk about, a lot of topics that we will be learning about. So every single thing will be covered in detail. Okay, so never think that this is all. This is not it, right? So there's more to it. Okay, so let's move on with the video. What is this? Fidget spinners?
Galaxies.
Yes, galaxies, right? Not fidget spinners, right? So these are galaxies, other galaxies, just like the Milky Way galaxy. So you can see there are so many galaxies filled with galaxies. So if Milky Way galaxy has, millions and millions of stars, then even these galaxies also have millions and millions of stars. So if someone asks me how many stars are there in the universe, can I give an answer for that?
Of course not.
Of course not, right? So that's how much of stars you have. It's basically infinite. The amount is infinite. It goes on. It doesn't end. Okay, and if you read the subtitles of this video, you could see other galaxies as seen in the Hubble Deep Field images. Remember, I told you in the year 1990, we launched a telescope called the Hubble telescope. So that was able to see a very large distance in space. So these photos were captured using that. Okay. You can see the question. Yasodhini has asked a very good question. Yasodhini has asked, what is the bright thing located in the middle of the galaxy? Superb question. A really interesting question. Right? So there's actually a topic that is specially dedicated to learn about this thing in our astronomy. What is the brightest part in the Milky Way galaxy? What is in the middle part of the Milky Way galaxy? What do you think is present in the center of the Milky Way galaxy?
A black hole?
Yes, it is a supermassive black hole called Sagittarius A star. Okay, it's a supermassive black hole called Sagittarius A star. It's superb, right? It's really, 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 really massive. And even right now, while we are talking with each other and you guys are enjoying this video, that supermassive black hole called Sagittarius A star is consuming everything that's around it. All the stars that are around that Sagittarius A star black hole is being consumed. So they are just drawn inwards into singularity and they are disappeared for the rest of their lives. Yes.
So can I please ask the question?
Yes, you may.
Then why doesn't the black hole suck Earth up?
The reason why the black hole doesn't suck Earth up is because, let me show you, go back and show you this video again. Right. So here you are zooming out of planet Earth, and you can see the sun shrinking, and you can see all the neighboring stars that are around the sun, right? And then when you move forward, you could see this. You are able to see the spiral arms of the Milky Way galaxy. Now look carefully where the sun is located. The sun is over here, right?
Yeah.
The Milky Way, the Sagittarius A star black hole is over here. And can you see this part in this white color region? So this is where you have the Sagittarius A star black hole. And this region is mostly, okay, so 90% of the time, mostly this region is filled with older stars, stars that are really, 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 really older than the sun, right? Ancient stars, which have been there for a very long time. Supergiants, you call them supergiants. Why you call them supergiants? Because when a star is about to die, yes, when a star is about to die, they expand, right? So they get fat.
And turn to black holes.
No, they don't turn into black holes. right? So it's like not
Sometimes they turn
not
into a
yet.
white
Okay.
dwarf.
Yes. So not yet. So before they turn into a black hole in this region, they are unable to turn into a black hole. The reason for that is because by the time they can even think of turning into a black hole, they are consumed by the Sagittarius spacecraft. Understood?
Mm.
So that specific region is covered with the most ancient or the oldest stars that were formed in the Milky Way galaxies. Whereas you can see
Okay.
the spiral arms, right? Can you see the spiral arms of the Milky Way
Mm.
galaxy? See, you can see the spiral arms, you have the younger stars, just like our sun. That's the reason why these spiral galaxies, okay, this is a type of galaxy called spiral galaxy. There are different types of galaxies like elliptical galaxy, irregular galaxy, like that. There are so many types. This is one type called the spiral galaxy, and the Milky Way galaxy is also a spiral galaxy. And the spiral galaxy is the most brightest galaxies that you will ever observe in the universe. The reason for that is this galaxy is filled with younger stars. Okay, just
Understand.
like just like humans. Now you take a young boy, okay, who is at the age of 15 or 20, and
Mm.
you take an 8-year-old man, 80-year-old man, okay, 80. Who do you think will actively do work? Who? Will it be the 20-year-old boy or the 80-year-old man?
20-year-old boy.
20-year-old boy. The reason for that is he has a lot of energy within him, right? And he's always seeing, he's always active. He's always finding for something to do. Whereas the 80-year-old man has already done all the work. He doesn't have energy left. He's now at he's waiting till he dies, right? He had enough of his life, right? So he's weak. He doesn't have that same energy or the same enthusiasm that he had when he was 20 years. That's the same with these stars as well, right? So there's something called fusion. Now I don't want to go into that because it would be too confusing and too much information. So when a star is formed, when a star is young, it has a lot of energy in its core in order for it to burn and use it as fuel. In order for it to burn and use it as a fuel as what? To emit light and heat as radiation, just like the sun. So when you go out, you will see the sun is emitting light, and that's why the entire place is covered with sunlight. And not only the light, if you stay out for too long, you would feel the heat as well, right? So the sun is giving out heat and light at the same time. So if you have more energy present in the core, it can produce more of it. If you have less energy in the core, it will produce less of it. Okay. So now I hope you understood. Nipa,
Understood. Yeah, I understood.
perfect. So that middle part, Yasodini, is where is the supermassive black hole is located. Okay, so the name supermassive black hole is called Sagittarius A star. And you would also ask how will a black hole look like? So you could see that behind me, right? So currently now I'm conducting this class not from Sri Lanka. So I have traveled millions and millions of kilometers away, and I'm in space. I'm actually uh, standing in front of a black hole. So you can see that's how a black hole will look like, a supermassive black hole. Can you see behind me? There's a black hole. Right? So I don't want to go much closer to it because I'll get pulled in, right? So then I won't be able to conduct classes. So you can see behind me. So that's a supermassive black hole. So the black hole in the middle of the Milky Way galaxy, Sagittarius A star, also looks kind of similar to that, which I'll be showing later on in this astronomy camp.
So, can I ask another question if it's not a trouble?
Yes. No, not at all trouble. You may ask a lot of questions.
If I go inside a black hole and somehow I'm still alive, what would I see?
Wow, very good question. So this is how it works. Okay, it's a very how do I give the answer? It's a very interesting and a tricky answer for this question. So you have this black hole, right? So this black hole, unlike other things, now if you take me for example, I'm a guy, I'm a foodie, right? I love to eat food. So any food you bring to me, I eat it. Now this black hole behind me is also a foodie. This guy can consume anything in the universe, whether it's a planet, whether it's an asteroid, whether it's a star. This guy can consume anything, right? Irrespective of what it is. Now, the fun fact is that it can also consume light. Imagine I shine a light onto it. Okay, so I have my phone over here, and I have this what do you call this? This torchlight on my phone. Now, when I put this torchlight onto this black hole, it will consume this light. This light will be sucked into that black hole. So that little part where you can see that black color hole in the black hole is where you call as singularity. And every single thing fall into the singularity. And when everything the thing falls into the singularity, till now scientists say that whatever goes into singularity doesn't come out. That's the end of it. No one knows what exactly is happening inside singularity. The reason for that, is because now let me show you something. Okay, so I have a sanitizer bottle with me. Can you see the sanitizer bottle? Guys, is the sanitizer bottle visible?
Yes.
Yeah,
Why are you able to see the sanitizer bottle?
we have eyes.
Okay, all right. What's the other reason? You can see the sanitizer bottle.
And there is light.
There is light. Exactly, Michelle told the right answer. There is light. Okay, so the light is shown. So there's a light on top of my head. So that light is, is reflected from the surface of this sanitizer bottle, and that reflected light is entering into your eyes. Nivan's eyes, Anaya's eyes, Dimet's eyes, Michelle's eyes, and Yasodini's eyes. That's the reason why you can see this. Now imagine if I switch off this light above my head. Okay, hold on a second. Let me switch off this light. Now it's fully dark. Now am I visible like the way how I was visible earlier? Earlier you were able to see my face, right? You were able to see this beard and all that. Now is everything clear? Can you see the features in my face like how it was before?
No.
No. The reason for that is light plays a very huge role in seeing things. And that is why at night, okay, you forget about night. These days they always cut the power, right? You always have power cuts. So suddenly you're watching TV or enjoying your time with your family around 8 o'clock or 9 o'clock in the night, and these people cut the power. There's a power cut. Then what do? You start getting panicked, right? You are like, okay, mom, dad, where are you? I can't see you. Bring the candle, put on the torchlight. I can't see. Where do I go? Where's my room? You start struggling. The reason why you start struggling is because your eye cannot see anything. Now, does that mean that you're blind?
No.
You're not blind.
No,
Your eye is
because there is
functioning.
none.
Exactly. Your eye is functioning. Your eye is working. It's perfectly normal. But the only thing is, without light, even your eye is useless, right? There's nothing that you can see. So the same goes with the black hole. So since black hole consumes light, it doesn't reflect anything. There's nothing. There's unable for us to see what is within the black hole. But still, scientists have come up with few theories about what is inside the black hole, right? So they say that things when you put a planet. Okay, we'll take a planet because we can't take humans, and because that won't be a very good example. So just imagine we take a planet. We take planet Earth, and there's a black hole behind me, right? So this is a fictional black hole, not a real black hole. It's a live black hole. So imagine I bring planet Earth next to this black hole. What's going to happen to planet Earth? Planet Earth will be pulled like a spring, like a rubber band. So planet Earth is like a ball, right? It's spherical. It's spherical. So this spherical planet will be pulled like a rubber band into the singularity of this black hole. Once it is pulled and once it goes into the black hole, scientists say that this planet or any substance that goes into the black hole will be compressed, crushed, squeezed into a little tiny space. Imagine this entire Earth is crushed into a size of 5 rupee coin. Can you imagine that? The planet Earth itself is very huge, right? It's very huge and it's very heavy. It's very big, massive. Imagine I take this planet Earth and crush it, do something to that and make it very small, the size of a 5 rupee coin. That's how much powerful the black hole is. It has that ability to crush it. So that is just one theory. And the other theory is that since this black hole has a very high gravitational pull, and since this black hole is able to bend space-time, right? Since it is able to bend space-time, that's the reason why the black hole looks like that. Okay, now you might not understand what bending space-time means, and I'm not going to. Yes, Tim.
I can only hear you a bit slowly.
Okay. How about now? Am I audible? How about others? Tuan? Yes. So Dini, Anaya, am I audible?
So I can hear you.
Yeah.
All right. Anaya also can hear me. What about what's his name? Nivan. Yes. Nivan, am I audible? Okay. Januki? Hello. Januki is shy. Why is Januki shy? Okay, Januki, don't worry. You can always speak up. Okay. So you don't have to be shy. Okay, Januki? All right. Okay. Yeah, how this black hole bends space and time, I'm not going to explain to you in much detail, but just imagine, okay, this space, this black color space that you are living in, that we all are living in, is basically like a fabric. What does a fabric mean? What is
A
the fabric?
piece of silk,
Huh? Like a
silk
cloth,
woven
right?
into a
Cloth.
coat.
Yes, some piece of cloth, right? So that's what we basically call as fabric. So scientists say that space is also a fabric like this. Okay, this is not a fabric, it's a book, but just imagine this is a fabric, right? So what happens when you put something on this? This will start bending, right? Like this. Yes or no?
Yes.
The more heavier the object, the more it will bend. Yes or no?
Yeah.
Yes. So black hole is one of the objects in the universe which has a very high gravitational field. Okay, and it's very dense. Okay, so not like the sun, not like the earth or anything. Just imagine if I keep the sun, it will bend. If I keep the earth, will it bend the same way how it bent for sun?
No.
No. So now the black hole, okay, just an ordinary black hole, is like million times powerful. It has a million times powerful gravitational field than the sun, a normal black hole. Then just imagine a supermassive black hole, the biggest of all, the monster, just like the one I have behind. These guys can bend space-time so much like this. Sometimes scientists believe that the space-time gets bent, and at a certain stage, what happens? To break, right? There'll be a tear. Understood? Now earlier, you guys, I'm not sure if you all remember this. When you all were kids, or when you might have seen babies, that mothers put these babies in the cradle, right? And they rock them. Now imagine you jump into that cradle, or not you, I jump into that cradle. Now I am big. I'm 22 years old, and I'm really heavy, and I'm not a very tiny guy, right? I'm big in size. So now I jump into that baby's cradle. What is going to happen to that cradle? Can I rock in that cradle like a baby? No, right? There'll be a hole in the middle of the cradle because of my weight. So the same thing is going to happen with the black hole. Because the black hole is really heavy, the fabric will tear and there's going to be a hole in the space-time. Now you might be wondering, hole in the space-time. How is this even possible? How can there be a hole in the space-time? Right? You might be wondering. So this hole is not like the hole in the fabric that I'm talking about. Now this is where it's going to get really interesting. Okay, this is where that Spider-Man thing is going to come. So these people, they say when the space-time gets a hole, now whatever falls into this black hole escapes from this hole which is created in space-time, and this hole leads to a different universe, a parallel universe. Now this is where that parallel universe talk comes into action. Now those who have watched Spider-Man will remember about this. I think all of you would have watched Spider-Man, right? Anaya, Vishal, Yasodini, Nivan. You guys watch Spider-Man? So in Spider-Man, you saw different Spider-Man, right? Tobey
Yes.
Maguire, and the other guys, all these people, they get set, right? They all, three people come from three different dimensions, right? So they just say, so they are saying that they are from different parallel universes. So people believe, scientists believe that this Milky Way, these black holes can actually be a gateway to a different dimension or a different universe. Yes.
What is a white hole mean?
Yeah, so white hole is basically kind of like the opposite of a black hole. So black hole absorbs everything. A white hole basically emits out everything. But the problem with a white hole is that scientists have actually discovered black hole, and black hole is a fact. What does it mean to say a fact and a theory? A fact means something which is proven and has evidence. A theory means doesn't have evidence or doesn't have proof. Understood? So now I'll tell you a fact. Okay. Uh, Tuan. Tuan is a boy. Is it a fact or a theory?
Theory.
It's a fact.
It's a fact, right? Can't be theory. Right.
How would you know his name?
Hello?
Then how would he know his name? How would he know his or her name?
Exactly, right? So he's a boy. Obviously, he's a boy, right? Tuan. So then that is a fact. Now, theory. Okay. Now I'll say in the year 2030, Tuan will be, let's say, the president of Sri Lanka.
What is the theory?
Yeah.
That's a theory. Now that we don't know. We don't have any proof, right? So now Yasodhini here is like, how can you say that Tuan is going to be the president of Sri Lanka? What proof do you have? Where's the evidence? This guy has not even been in the parliament. How can he become the president? What evidence are you, do you have in order to prove it? I don't have evidence. I don't have anything. So therefore, this is just a theory. Okay, this is just a basic idea that I'm giving you an example. So black holes is something which is proven. Its existence is proved. But white holes, on the other hand, is not proven. It's just a theoretical concept. Understood? Who asked that question? I think Dimet, right? Yes, Dimet. So white holes are just a theoretical concept. It's not something which is available in the universe. Okay? All right. So Yasodhini, you got the answer to your question?
Yes, sir.
All right, perfect. So we'll watch the video from this part onwards, okay? Now what is this? It's called a cosmic web. What is this web? Spider-Man's web? No, it's not Spider-Man's web. This web is not the spider's web also. This web is made up of full galaxies. And so these white color strings that you can see over here are all galaxies, galaxies, galaxies. Now this might just give you an idea of how many galaxies that might be there, right? Unimaginable, infinite amount of galaxies. These are all web of galaxies, right? So many galaxies. We don't even know where the Milky Way galaxy is in here. So now compared to this web, Milky Way galaxy is just a piece of dust. Not even a piece of dust. It's just nothing compared to this. Okay. This is what we call as the universe. So everything that we will be covering in our astronomy camp, the black holes that we know of, the galaxies that we know of, the supernovas, the nebulas, the what else? The planets, the stars, every single thing is all inside this universe.
Excuse me, sir. Can you remember? You
Yes.
said zeros. You said many zeros. 0.1 is
Yeah.
that's the percentage of the space found.
Yeah.
Is this part included?
No. So basically, you could see that the universe is denoted as a big ball, right? As a spherical sphere. Understood? So this one is not actually a real photo of the universe, because no one can actually take a picture like this, right? So we are also inside the universe. So then how can we even take a picture of the, the entire universe if we are inside? There has to be something placed outside the universe in order to take a picture of the universe, right? So this is just a mathematical representation of how the universe will look like. Because this universe doesn't stay the way how it is like this. It keeps expanding every second, every millisecond. The universe is expanding, and they say that this universe is expanding, at least at the speed of light, more than sometimes the speed of light. So it's very hard to, reach the edge of the universe. We can't even think of reaching the edge of the universe because the edge of the universe is always expanding, 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 expanding. So now they have just summed up everything and they're just showing it as one. But in reality, we don't know any of this.
Yeah.
Understood, Deva? Just to give us an idea, of what the universe is, that's why they're showing it. And now the reason why they're going to show us the idea of this, what the universe is, now you will understand why they're going to show it. Because they're going to show you the multiverse. In another few seconds, you will understand why. Is that part? Everyone has a question. Now the previous batch, our first batch of astronomy camp, when Dr. Julianians joined, most of the students asked this question: what is the multiverse theory? Is the multiverse theory true? Is it false? Right? So this is what it means. See how many universes are there, like our universe. So what the multiverse theory tells us is that, since there are a lot of universes outside our universe, there is a possibility that there's a copy of us in some other universe. So Nevan is here learning astronomy, right? So there might be another copy of Nevan somewhere else with a different name who might be doing something else. Understood?
Yeah.
Vishal is here seated with his camera in front of his face and he's observing the class and he's learning about astronomy. There might be some other Vishal somewhere else in some universe. That Vishal might be the Batman of that universe. Who knows? Can't say, right? And there might be another Yasodin. So Yasodin is seated here, observing the class in a different universe. Yasodini might be doing something else. She might be a teacher. So that's where they say that there are different copies of the same universe. getting goosebumps watching it. What do you think? What do you think about this?
Cool.
Cool. Okay. Everyone says it's cool. Others,
Cool.
even
That's awesome.
Jasodini, what about you?
It's very beautiful.
All right, super. What about you, Anaya?
That's spectacular.
Sorry?
That's spectacular.
Exactly. Spectacular.
A good editing.
Yes, Krisha?
Good editing.
Yes, good editing as well, right?
Yeah.
So that's how vast the universe is. Now, sometimes you might not understood certain things. It's fine because that's why we have the astronomy camp, right? So astronomy camp is not one day; it's 3 months long. Every week you will have a class, and the reason why you have a class every week, and the reason why your class is going to be 3 hours long, is for this reason, right? So we're going to take a specific topic and learn about that in detail. Now you would have seen someone asked a question, I think Yasodi. She asked a question about the black hole. It's located in the center of the Milky Way galaxy. So when I started explaining about the black hole, did you, I don't know if you all noticed this, but if you all did, you would have seen that I was explaining a lot of things, right? There were so many things that I told, okay, now I don't want to go into that in detail. I don't want to go into that in detail. Because even if you take a very slight topic, a very small topic like a black hole, even that there are so many things that you can talk under it. So the same applies for others as well. About a planet, about the formation of a planet, about the solar system, about the sun, about the asteroids, meteoroids, comets. Like this, there are a ton of topics out there. Okay? So we are trying to cover every single thing and give the maximum as possible. So now we have another question and answer session. Okay, so now you guys are watching, you are enjoying the video. So now, again, another question and answer. So if you have any questions, you can ask. Got any questions?
No.
All right. Okay, perfect. So now I'll just give you all an idea about the astronomy camp. So this is how your astronomy camp is going to, work. Okay, so currently we have a Sunday batch, that is tomorrow, and then we have a Monday batch as well. And you guys will be the Saturday batch. Okay, so that's going to be every Saturdays, just like today. So when is it going to start? It will start at 3 p.m. Every Saturday, 3 p.m. your class is going to start, and we will finish at 6 p.m. Okay, and then at 4:30 p.m. you guys will have a break. Your class starts at 3 p.m. and at 4:30 p.m. you're gonna have a break of 20 to 15 minutes, sometimes 15, 20 minutes, depending on how quick the students join after the break. Okay, so you will have probably, let's assume that's a 20 minutes break. So from 4:30 to 4:50, you will have a 20 minutes break, and then you will start the class again, and the class finishes at 6 p.m. Understood.
Okay.
So that is basically the structure of the session of the astronomy camp. Now,
Including
after
today?
you complete, including today, let's hold on. I'll come to that. Okay, really good question. Nivana asked. It's an introductory lesson. So let's see. Right. So I'll come to that. So after every session, right? So after every session, after this 3 hours is done, that's when I will announce the task that you guys have to do. Okay, so now what are these tasks? Now you might be scratching your head and thinking too much. Oh my God, I have homework. No, this is not a homework. Okay, don't ever think that this is homework like the homework that you're given at school. Okay, this is very easy, very fun, and going to be very interactive. Okay, it's going to be very, very easy in the sense you're going to have 1 week time. So imagine your first class is next week. Okay, your first class is next week. Your second class is going to be a week after that. So how many days you're going to have in between? How many days? 7 days. 7 days, right? 1 week. Right? So you have a class on Saturday, and the next class you will have again on the other Saturday. So in between you have 7 days. What do you call it? Work. You have 1 week.
Yeah.
Got it. So it's
I
not
got
like
it.
Yes. So you have not 1-2 days to work. You have exactly a week for you to work on these tasks. Okay, so it's definitely not going to be hard. It's definitely not going to be a burden. And these tasks are going to be of three sorts. Okay, so you will have to record a video of what you learned in the class. So you will record the video and you will send it to us in WhatsApp, and we will post these videos in our social media platforms like YouTube, like Facebook, LinkedIn. Like this, we will post. You would have seen other videos as well of our other students from the other batches. You guys would have watched videos, right? So it's there in YouTube as well, and I will show those videos to you once I finish explaining, so that you get an idea. So that is a task. That is task number one, and task number two is dependent on this topic that you all will be doing. Okay. Now, for example,
Okay.
the first topic of our astronomy camp, the first class of our astronomy camp is going to be about the solar system. Okay. So in the
Yeah.
solar system, so in the solar system camp, the day one, your this one, what do you call, your activity will be like, hold on, let me up this first class activities about first class activity. Hold on, let me open the lesson file. Yes. So first week plus activity is about, you have to draw your favorite planet and its natural satellite. So like that, you have different what do you call, activities. Like you have to write a report, you will have to design a model, uh, you have to do a research. Like this, you have different kinds of activities that will be given for different sessions. Okay, not really hard activities. Don't ever think this is hard. Very easy activities. You all have 7 days to do it, so definitely you all can do it without any difficulties. So that is task number two. What is task number three? Task number three is self-evaluation. What is this self-evaluation? Right? So remember, I told you this astronomy camp is going to be very helpful, and we are trying to make this as useful to you as much as possible. Right? So if you guys come on Saturdays and if you learn only on Saturdays, and the next week and the remaining days you don't even look at astronomy, or you don't even go through the notes of astronomy, what is going to happen? You will lose track of it, right? You will lose whatever you have learned. So in this self evaluation part, what you basically do is you go to internet. Everyone has internet these days, right? All of you guys will have a computer in your house. If you don't have a computer, you might even have a phone. So you go to internet, you search for videos about astronomy on YouTube. If you don't want to watch videos, you can search of topics in Google, like let's say about Sagittarius A star, the black hole. You want to know about it. So you type about it on the internet and you do a research and you learn about it. Understood? So that is what self-evaluation means. So every week you gotta do a self-evaluation. You have to learn something new about astronomy. So while you are learning something new about astronomy, you will get something new, as well as you will find a lot of new questions that you may be facing with. So these questions, you can note that down in a piece of paper on your book. And whenever we have a class in Saturday, you attend the class and you ask these questions. Understood? So those are the three activities. What is the activity number one? You record a video, send it to us in WhatsApp, and we will post it in our social media platforms. Activity number two is you either draw a picture, you design a model, you do a research, or you write a report about certain. Yes.
Is sun a star?
Yes, of course. Sun is a star.
So,
Yes.
so are you going to teach us about some like astronomy, mathematics, like those things? Astronomy, some.
Yeah. So Vishal asked a really good question. Okay, so is mathematics involved in this? Right. So in general, let's say once you finish college and you want to go to university and pursue your career in astronomy. If you want to pursue a career in astronomy, mathematics is a must. Okay, you have to know mathematics. Without knowing mathematics, you can never become an astronomer or an astrophysicist. So does that mean that you will be learning astronomy in this astronomy camp? No. In this astronomy camp, it is more specializing on the theoretical part of astronomy. Okay, not the practical part of astronomy. So you don't have to do any maths. The reason for that is most of the students here are very small, understood, and they don't have really, vast knowledge in mathematics. And that math, even if you all know mathematics, the mathematics that is needed terms that are related to astronomy are very complicated. There's no way that you guys can handle it. Understood?
Yes,
But
sir.
No.
but there is another program that we are working on, which we will introduce in near future in few weeks. Is something called the Advanced Astronomy course. With that, we will also, with the Advanced Astronomy course, there will be a part paleontology as well. Because that's going to be about dinosaurs and advanced concepts of astronomy. So what is that course about? Who is going to learn this course? Now, those who are in our astronomy camp, those who finish our astronomy camp, those who learn all the basics in astronomy, those who know everything that's happening in space right now, they have some idea. And those who wish to continue more than this, they can join this advanced astronomy course. Now, in this advanced astronomy course, there will be certain things that we cannot cover in this basic astronomy course, right? Certain things like, for example, let's say, I'll just tell you one example. We have the sun. Sun is always burning, right? It's giving out energy. The reason for that is, remember I told you that there is a massive release of energy within the core of the sun. This release of energy is happening due to fusion. The fusion is a reaction. Now, how does fusion happen? Now, in this basic astronomy camp, I will just tell you one thing, simple. It's because two hydrogen atoms fuses together, and when this fusion takes place, it becomes into a helium atom, and this releases energy. But in the advanced astronomy camp, I will explain this in very detail, to the very core of it, from A to Z. Understood? But now, if I explain to you that in this camp, you guys will be really puzzled, and you guys will, lose consciousness if I explain all of that right now. Okay, so that's why we go with the basics. And then once your basics are done, and if you're still interested in astronomy, and if you want to pursue your knowledge in astronomy, and if you're still curious, if you want to know more answers, then you move on to the advanced astronomy and paleontology course. Understood, Misha?
Yes, sir. And the advanced astronomy class, is it available now or in the nearby future?
No, we haven't still. It's not available to join, but it will be available from April onwards, because our first batch of our astronomy camp is about to finish. They are in the third month. First week is also done. I think another 3 more weeks for them. And after another 3 more weeks, they'll be finished with the astronomy camp. So those students, most of the students from that camp, they're interested in joining the advanced astronomy camp. So they'll be joining us for that. So our advanced astronomy camp, at the moment, we haven't started it, but we will start from next month, from April.
Okay, sir. Thank you.
All right. And then we will have guest speakers joining us for that as well, right? So like, for example, last week we had Mason, right? Mr. Mason Hintermeister. The reason why he joined us is because to give you all an idea about this advanced astronomy course. Just remember I told you in this advanced astronomy course, it's not only about astronomy, you have part paleontology involved as well. So not only Mr. Hintermeister, other people also will join us, right? Like paleontologists, astronomers, astrophysicists. There's more to come. This is not the end of it. All right, guys. Okay. So now coming back to our camp. Okay, so now in our camp, so those are the 3 activities. What is the first activity? You record a video, send it to us. Second one is you either research, you write a report, you draw a picture, or you do a module. So that is depending on the topic, there is different activities. Okay, so you do that. Third is what? Self-evaluation. What do you do in self-evaluation? You do your self-study. You learn a new topic in astronomy. How you're going to learn it? You can either search it in Google, read articles, read magazines, go through encyclopedias, or if you're someone who is not that into reading, you can even watch YouTube videos, YouTube tutorials regarding astronomy, which is freely available, readily available. So those are the 3 activities. Now, why have we given these 3 activities for you guys? The reason why we have given these 3 activities for you guys is because of your own benefit, right? At the end of the day, I'm not going to benefit from this. No one is going to benefit from this except you guys. Okay, so the more you all do this, the more you all actively participate, it's going to be better for you guys. Okay, so those who record videos and send to us, and those who do the tasks, what I'm talking about, the research and all that, the writing report, those who do that every week, we will select a student who has done it like without missing, like who has given their maximum, who have done all the tasks on time. We will select that student, and that student will be awarded. Okay. So at the end of the third month of astronomy camp, for every batch, batch one, batch two, batch three, even the batch that comes after your batch, like batch four, batch five, whatever number of batch, all this batch at the end of the astronomy camp, they will have an awards day. This awards day will be physical, right? So we will have a place. We will call you guys. So all of you guys will be present. So it's going to be really interactive. So every day we all communicate using devices, right? It's all virtual. I have not seen Mishal. Mishal haven't seen me. I haven't seen Nevan. Nevan haven't seen me. I haven't seen Anya, Yasodhini, Dimet. No one have seen each other. So on the awards day, it's going to be really fun. It's going to be really cool. Right? You guys can all come together. You all can talk with each other. It's going to be really cool. And we have planned very fun activities as well. And along with the activities, there are going to be an awards day. So those who perform well will be awarded in the awards day. Understood? So if you all want to win, if you all want to get awarded, take this into your head. And when we start the first session, and once we give out the activities, make sure that we all do it. Okay, guys?
Yes, sir.
Okay. So you got any questions? Another one more thing, I mentioned this earlier as well, and I mention it again. Make sure that you all join tomorrow, because tomorrow you have what do you call uh, Dr. Julia Onions will be joining us. He's an astrophysicist kind of program, so he'll be joining us tomorrow. Okay, so
So,
yeah, so he'll be talking about dark matters and dark energy. So it's going to be basically like a lecture, just like the one we had with Mason Intermester. So he'll be explaining about those two matters. And then once that is done, there'll be a quick Q&A, a question and answer session where you guys can ask questions. Okay, so it will be tomorrow. So you guys make sure that you are going tomorrow. All right. Understood?
Yes, sir.
Yes. And I checked again. So today we'll be starting the first session, because last week also we had the paper test. So this week also if you have it, won't be very good. So we'll start the first sessions now. So now if you see, the time is 4:30. So every day, every week, every session, 4:30 is the time we have our break. So I'll go for a break and come back in another 20 minutes. Okay.
I can leave now.
No, you go for a break and you come back in another 20 minutes.
That
You
means I
switch-
can I can leave and come back.
Yeah, you can. If not, you can switch off your camera and microphone, and then switch it back on when you come back.
Okay, sir.
Okay.
Excuse me, sir.
Yes.
How much time is the break?
Now it's break time. So in another 20 minutes, we'll start again. Okay, Dimit?
Okay.
There are 8 planets in the solar system.
Wait. You guys had your chance in the spotlight. It's time to talk about the dwarf planets in our solar system.
There are 5 dwarf planets in our solar system, and we revolve around the sun. 4 of us live in the Kuiper Belt. As far as planets, we're the smallest ones.
I'm Maki. I have no atmosphere. I was discovered in 2005. I am one of the reasons Pluto lost his status, so naturally we do not jive. My name is Aries. I'm more massive than Pluto. I am big, but I'm lots of fun. 557 is the amount of years it takes me to revolve around the sun.
There are 5 dwarf planets in our solar system, and we revolve around the sun. 4 of us live in the Kuiper Belt. As far as planets, we're the smallest ones. This is a size comparison of objects in our universe. We'll start with the smallest and go to the largest, most well-known objects we know, of course.
I am Ceres, I am a dwarf planet. Maki's a dwarf planet as well, but didn't plan it. I am Haumea, a dwarf planet in this group. Pluto is a dwarf, but used to be a planet, it's true. Aries is a dwarf planet in this mix. The Earth's moon is where your eyes are transfixed. Mercury is here, an official planet. I'm the planet of Mars, I'm sure you all know this. I'm planet Venus, my size you may think is large. Planet Earth is next, and the humans think that they're in charge. Neptune's a planet in our solar system, wow. Planet Uranus is here, I wish I could take a bow. Planet Saturn has rings, if you think I am big. Check out planet Jupiter, I hope you can dig.
This is a size comparison of objects in our universe. We'll start with the smallest and go to the largest, most well-known objects we know, of course.
I am the sun, a yellow dwarf that isn't far. I am Sirius A, a main sequence star. My name is Pollux, a red giant star, it's true. Arcturus is a red giant star, this I thought you knew. I'm Aldebaran, a red giant star, that's me. Hi, I'm Rigel, a blue-white supergiant, you see. I am Betelgeuse and I'm a red supergiant in class. I'm Antares, I'm a red supergiant that won't last. VY Canis Majoris, a red hypergiant star. I'm UI Scuti, the biggest red supergiant this far. I am the Milky Way galaxy and you live in me. Now let's all sing the chorus together with glee.
This is a size comparison of objects in our universe. We'll start with the smallest and go to the largest, most well-known objects we know, of course. This is a size comparison of objects in our universe. We'll start with the smallest and go to the largest, most well-known objects we know, of course. We are some planets, all different in size. Here's our planetary size comparison for you live. We'll look at each planet, measured by their radius here. There are so many planets that will appear.
I am Ceres, I am felt as the largest.
Hello guys, are you there? Yes. Anaya, what's with the camera? Is camera all right now? Can you adjust your camera if you don't mind, Anaya? Because we can only see your screen. This class is recorded, so it's better if everyone's face is visible. Because only if the forehead is visible, it won't look nice if someone goes through the recording. I hope you all understand. Okay, so everyone is there, right? And Dimet, are you there?
Yes, sir.
Perfect. Okay. Right. So now the introduction part, everything is done. I hope all of you understood how this astronomy camp is, will be carried out, and then what is the benefit of learning astronomy. All of those things are covered. So today, without wasting time, we'll move on to the first session. All right. So today will be the first session. So I think Nivan asked if today's lesson will be a full class. So yes. So today will be the full class, right? So today we'll go with the first lesson, and so Dini also asked, will we receive the task today? Yes. So once we finish today's lesson, every one of you all will receive the task. Okay. So let's see. So today's lesson, the first lesson today is about the solar system. Okay, solar system part 1. There are actually 2 lessons: solar system part 1 and solar system part 2. So this week, today, we'll be learning about solar system part 1, and next week we'll be learning about solar system part 2. Right, guys? Okay. So now in solar system part 1, what are we going to learn about? Okay. The first thing that we are going to learn about is the formation of our solar system. All right. Okay. So now, how did the solar system form? How did it come into existence?
By the star, by the sun.
All right, okay. Vishal says by the sun. Devan?
By the Big Bang Theory.
By the
Theory
Big
and
Bang. Okay. All right. Okay. We can't actually say the Big Bang theory because the Big Bang theory happened 13.5 billion years ago.
Yeah.
All right. According to scientists, they say the Big Bang theory happened 13.5 billion years ago, whereas the sun and the planets were 4.5 billion years old. Okay, so that means much after the Big Bang. Okay, so many years after the Big Bang happened, only then our solar system was formed. Okay.
The
So
Big Bang
remember when I was
theory.
showing the Milky, yeah.
The Big Bang
Yes.
theory created our galaxies and the universe. Our sun was created by nebula, gas of
Yeah,
lava.
so that's really good question Vishal asked. So Vishal, so it's something like this. Okay, so have you guys heard about someone called Albert Einstein?
Yes, sir.
Right? Not Albert Uncle, Albert Einstein. Okay.
No, sir.
Albert Einstein, not heard, Dimit? Okay.
Yes.
All right, don't worry. I'll show you a picture of him. Okay, so he was known as the scientist of the century. That's how famous he was, and that's how much work he has put into the field of science. He has discovered a lot of cool, important concepts in the field of astronomy, mathematics, and science. Understood? So he's one of the leading scientists. So according to Albert Einstein, and it is even proven now, is that matter, right? There's something called matter. Now, what is matter? Matter is basically anything that is there around us. Now, my body is a matter. The laptop, which is in front of me, is a matter. Nevan is a matter. Now, Nevan has books behind it. That's a matter. Our house is a matter. Our planet is a matter. The gases are matter. The star is a matter. Exactly. Every single thing is a matter. Understood. So what Albert Einstein said is that there is a set of matter which is available in the universe. That set of matter, it is what being recycled. Now, for example, let's say now you would have seen in schools and in the news and everything, like they tell you once you finish drinking, what do you call these soft drinks, you have these plastic bottles. They tell you not to throw these plastic bottles. Why? Because they tell you to collect these plastic bottles and you give it to the company. And what will the company do? They'll take this plastic bottle. Right. They'll take these plastic bottles. They'll They'll melt it and they'll make new stuff out of it. Exactly. So what Albert Einstein told is basically all this matter, not this plastic bottle. Now I just took the plastic bottle for example. He said every single thing in the universe is just only that much. There's nothing more than that. Whatever is there right now is there. That's it. Nothing is being created newly. Therefore, whatever is formed or whatever is born right now is basically a recycle of something which was long time back. But just to give you an idea, I took Nevan as an example. I'll take now who's there. Let's take Anaya. Okay, Anaya, how old are you, Anaya? 9 or 7? 11 years.
9 years.
9 years. Okay. So Anaya says she's 9 years old, but that age is just the biological age of Anaya. But scientifically speaking, okay, theoretically speaking, is Anaya actually 9 years old? She's not. She's basically 13.5 billion years old. Anaya is 13.5 billion years old. Dimit is 13.5 billion years old. Nevan is 13.5 billion years old. Yasodin is 13.5 billion years old. Vishal is 13.5 billion years old. I am also 13.5 billion years old. So we are basically stardust. So before we actually became humans, we were something else, So that's what scientists are saying. So this is all getting recycled. Okay. So after the Big Bang, everything came into existence. That is true. But after everything came into existence, things have been formed and things have lived and things have died in that time. Just like the stars that I'm talking about. Stars are formed, stars live,
Stars.
and then stars die. Exactly. So same thing will happen to our sun as well. So how was the sun formed? Sun
By
was
nebula.
formed, yes, by a nebula. Okay. So what is this nebula actually? So nebula is basically a remnant. What is a remnant? Remnants means something which was left over, something which was, a byproduct of something. Okay. So a debris of something. That's what you call as a remnant. Okay. Remnants of something. Okay, so basically what they say is there have been some kind of a huge star. So that star has collapsed and it has died and a nebula has formed. And as a nebula, what you basically call a nebula is actually a star nursery. What do you mean by a star nursery? What do you mean by a nursery now? Forget about star nursery. What do you mean by a nursery? Yes, never.
A baby
Place,
star.
a place where all the young kids stay.
Yes, all the young, mostly infants, right? Babies. Not even kids like your age, right? So
Yeah, yeah.
Nevan, Dimet. No, you guys don't go to nurseries. No, you all are much older for that, right? So basically, people who are in the nurseries are very young babies, right? Infants and toddlers. So star nursery means a nebula is basically no nebula. It's a very big concept. Okay, there is actually a lesson dedicated for nebula itself, but I don't want to go into that because that will be covered in the other parts of our astronomy camp. But for now, just remember that nebula is a star nursery, and a nebula is where a star is formed. Okay, so wherever if you see, if you become an astronomer, if you become an astrophysicist in future, and if you're observing the sky, and if you see a star is being formed, that place is a nebula. Okay, so what is this nebula? Nebula in space, okay, in this in this wide area which we call as space, this black voidness, this huge area where you have everything, there are certain regions or certain areas in this space where it is much denser and more, what do you call, the gravitational pull in those areas are very, very, very higher than the other areas. Okay, these areas are covered by dust particles. These areas are covered by hydrogen gases. These areas are covered by huge rocks, space rocks. Okay, this is basically what a nebula means. And now I'll show you a picture of a nebula. Okay, once I finish explaining, I'll show you a picture of a nebula so that you get an answer. So in this nebula, what happens is, since it is more denser than the other parts of space, since this place is more gravity is very high, all these gas particles, all these dust particles, all of them starts, you know, clumping together. They all start getting attracted to each other, just like magnets. What happens when you keep magnets together, close to each other?
They get
They start
attracted
getting,
and
exactly. They start getting attracted to each other, right? If you keep more magnets will get attracted to each other. If you keep increasing the number of magnets, the more bigger the magnet will become, right? It will attract, and the small one will become big one. The big one will become even bigger than that, and keeps expanding. So these clumps of dust, these clumps of gas, everything started getting crushed into a small ball, okay, into a small sphere. Start crushing because gravity is squeezing everything together. Okay, gravity is squeezing because gravity is not something which we should take simply, because gravity in astronomy, when you're learning astronomy, gravity is a very important concept. Okay, because most of the subjects that you learn in astronomy, gravity comes into play. So for those who don't know what gravity is, let me explain what gravity is. Okay, so today Mishal is learning, Nevan is learning, and I am also teaching. So am I floating in the sky while I'm teaching you guys? Am I flying right?
No.
no,
No, I'm
because the
seated on
gravity is
this
holding
chair.
you.
Exactly, the gravity is holding me. My laptop, is my laptop floating like this in the sky? Am I typing like this? No, the laptop is stick to the table. And the table, is my table floating in the sky? No, the table is stick to the floor. The floor, the building, everything is stick to the ground, to the earth. The ocean is stick to the floor. The mountains is stick to the floor. The reason why everything is stick to the floor and it is where it is should be is because of this force called gravity. So every object has a gravitational pull to it. The more greater the object, the more gravity it has. Understood? Okay. So now Earth has a certain amount of gravity. Now when you compare the moon's gravity with Earth, moon's gravity is just 1/10 of Earth's gravity. What does that mean? That means you take Earth's gravity, break it into 10 pieces, and that out of that 10 pieces, only one piece is equal to moon's gravity. So therefore, when you go to the moon, you can't do everything that you do in the Earth. Now let's say Mishal is here, right? Mishal is bored, and I was talking about space tourism. Remember I was talking about space tourism? Yes. So Mishal is very rich boy, so he is spending a lot of money, millions and millions of dollars, and he gets into a spaceship and he goes to the moon for a trip. And now he goes and settles on the moon, and he's taking out his laptop. He's keeping his laptop on the table, and he's seated on the chair. Do you think he'll be able to, sit like this and listen to the
No,
clouds?
because
No.
the moon gravity is so weak.
His laptop will start flying somewhere else. Mishal will go somewhere else. Exactly. He will start floating, right? He will not have control of himself. And sometimes he will start running. Let's say he's playing cricket or something. Okay, someone hits a six. The ball is flying over there. So Mishal is running behind the ball. Now why he's running? Without him noticing, now he's running in the, what do you call it? He's not running on the floor. He's running up like this. Because the gravity is so low, he has no control over his body. So different celestial bodies have different gravitational field. Okay, the same Mishal, who is now not having any control of himself, who is floating in the sky, and when he's jumping up, he jumps up like 2-3 meters high, right? So he's jumping like, when you jump here in Earth, you just jump only 1 feet, 2 feet, that's it, maximum. Now Mishal is thinking, okay, moon is also similar to Earth. Now what's the big deal? I'm jumping, and he's jumping. He's going over there, like what do you call? He can jump as tall as the lotus tower. Okay, so that's how high Mishal will be going up in the moon. Now the same Mishal is getting into a rocket, and now he's flying to planet Jupiter. Now he's expecting to do the same thing in planet Jupiter. Can he do the same thing in Jupiter?
Yeah, of course, the Jupiter gravity is so strong.
Jupiter's gravity is very, very, very stronger than Earth.
Yeah.
Now Mishal can't even do anything. Now Mishal is seated on the chair. He's putting the papers. Now I'm giving the break. Okay, I'm telling, okay, break time 20 minutes. Go and come back. You can go relax, or you can go to the washroom, have a tea, or do anything, and come back after break. Now Mishal wants to go to the washroom. Now he's trying to get up from the chair. He can't. The gravity has pulled him so much. Chair is also in the floor. He can't move or do anything. Full day, 24/7, 365, he will be on the bed, lying down. Because there's so much pressure on his body. Everywhere, hands, legs, mind, the head, the body, the legs, everything, every body part of Mishal is pulled towards the ground, unlike Earth. So therefore, he can't do anything. He's going to play high catch with Yasodhi. He's throwing the ball to Yasodhi. He's aiming really high and he's throwing the ball. The ball comes out of his hand and falls down. And the next one, Nevans throws the ball to Mishal, and Mishal wants to hit a six. He carries the bat and he hits the ball, bat falls, ball also falls in the same place. No six, no four, nothing. Right? So you can't play cricket, you can't do anything. So depending on the environment, the gravitational force also changes. Okay, so now I hope you all understood somewhat about what this gravity is. Now let's go on to that nebula again. Okay, so
what
now
about the
nebula
gravity of Mars?
Mars is a bit lesser than Earth because Mars is smaller than Earth. Mars has less gravity,
Okay.
but not as less than the Moon, but a bit less than Earth. So therefore, that's why now let's say I told you right in the year 2030 or something, people might most probably colonize Mars. So if people colonize Mars and if people start living in Mars, and if people give birth to children, right, babies, those babies, if they grow up in Mars, okay, if they have no contact with Earth, if they have never been to Earth, and if they only live on Mars, those babies will grow up to become giants. Okay, now let's say, for example, Anaya. Let's imagine Anaya was born in Mars. She was not born in Earth. So now when Anaya is born in Mars and after like 15 years, she comes back to Earth. She'll be like, 20 feet tall. You can't even touch her. She'll be like that. You know, if she wants to talk to someone, she'll carry someone and talk like this and put them down. So that's how tall Anaya will be.
How can a
Right?
person be tall in Mars?
The reason why Anaya grows tall in Mars is because there's no gravitational pressure on her bones. There's less pressure on her bones. Therefore, she can grow freely.
So no matter what, she will go higher and higher and never stop going.
She might stop growing because the human body has a certain capacity to grow, right? So according to that capacity, she will grow, but she will grow much taller than she is supposed to grow on Earth.
Came back from a search.
Understood. The same thing can happen to even
Yes,
us.
sir.
Even we are not too late. Okay, now I'm grown, right? So this is my final height. I will not grow beyond this because I'm not a kid anymore, right? So I won't grow taller than this. This will be my permanent height. But I can actually increase this height. You know how? I just have to go to space and live in space for like 1 year or 6 months. And if I come back, I'll be like 2-3 inches taller.
So if a baby
Because
is born in Jupiter,
yeah,
then the baby will
that's it.
be so short than us, right?
Sometimes that baby won't even live because the human body is
Yeah.
not, used to that amount of gravity. Sometimes the baby might die.
Oh.
So that is there, right? So now let's come to this nebula part. So nebula is a star nursery. So nebula, this is where a star is formed. So when a star is formed, what basically happens is this nebula is basically a gas cloud. Okay, that's how we define it. It's a gas cloud in space. Now, gas cloud in the sense, don't imagine the cloud that we see here, right, in Earth. Those white color clouds, that's not the cloud that I'm talking about. Okay? So these clouds are different. These are gigantic, huge clouds filled with gases, dust particles, and other space rocks. Okay. So because the pressure is really high and the gravity is also increasing, these particles, all of them, starts attracting with each other. The more the particles attract, the more bigger it gets. The more bigger it gets, the more gravity it has. Understood? So the more gravity, what it happens is it starts heating up, the pressure gets built up, the gravity also starts rising, and then the core of this, what do you call this spherical ball that is being built with particles and gas particles, this ball which is now being developed, which is being formed, becomes a core of the star, right? So of a star which is to be born or to be formed in future. So this core starts getting heated up. It gets heated up, and the gravity also starts increasing. And due to this gravity, particles around this what we call this core start circulating around this orbit. Starts going around this orbit. Okay. Now, for example, I'll just show you. I'll draw a picture and I'll just show you so that you all understand. Okay. So now let me share the screen. Okay, so now you have something like this, let's say. Okay, so you have a huge rock like this, right? This rock knocks with this rock. This one gets attracted with another rock. This other rock gets attracted with another rock. This entire thing gets attracted with this big rock. This whole entire thing gets attracted with another rock. So like this, they all attract with each other, and they get bigger and bigger and bigger with days, right? So the more the day passes by, the more bigger they get. And since they get bigger, the more gravity they have. And since they have more gravity, all the other small particles that are around this object that is being built, they start circulating this object. They start orbiting. So when they start orbiting, what happens? There is like a disk which is formed around this object. There's a disk. Like this, there's a disk which is being formed. In this disk, there are so many particles, gases, particles, everything is there in this disk, right? So even in this disk also, you have like this particles which are getting clamped together like this. Even in the disk, you have certain places. Like one is over here, other one is over here, other one is over here, other one is over here. Like this, you have certain parts. even on the disk. Okay.
Yeah. Sir?
Yes. So like this, there are other clamps also that are happening in this disk, and this middle part is getting hotter and hotter and hotter. Right now, this disk is what you call as an accretion disk. What do you call it? An accretion disk. Accretion disk. Understood? This disk around is called as an accretion disk. Now, this huge particle that is being built in the core of this accretion disk, in the middle of this accretion disk. Now, this is what will become a star in future. But now we don't call it as a star, we call it as a protostar.
Mm-hmm.
What is a protostar? This one.
Oh,
What is an
okay.
accretion disk? This one.
Mm-hmm.
Understood? So
I
now
understood.
what happens? Yes. So now what happens in this protostar is, now that the gravity is also increasing, now that the pressure is also increasing. Now, do you remember that I told you in the nebula you have a lot of hydrogen gas? Remember? Now, if you take the entire universe, the only element that is widely available is hydrogen. There's nothing that is more prominent as hydrogen. Oxygen, carbon dioxide, nitrogen, all of these are there, but hydrogen is what is widely available in space. So hydrogen in the core of this protostar gets crushed because the amount of gravity that is being built right now is very high. It is unimaginable. We can't even think of that gravity. Now, I was explaining to you about the gravity of Earth, the Moon, the Jupiter, and all of that, right? So the gravity over here is much larger than all of that, even greater than the gravity of Jupiter. So now this gravity not only has the power to crush a human, it also has the power to crush an atom. Now, those who don't know what an atom is, please raise your hands. You all know what an atom is? Yasodini, Nevan, Dimet.
I
You
know
guys
the
know what an
atom.
Nevan
I
knows
know what
what
is
an atom.
that.
Yes. Dimet, Dimet. Hello? Dimet,
Yes, sir.
do you know what an atom is?
No.
Right, okay. So basically, atom is called the building block of an object. Okay, you have different objects, right, around you. Now, my body is an object. My phone is an object. This sanitizer bottle is an object. My wallet is an object. My laptop is an object. All these objects that you see, Dinet, is all made up of atoms. Now, what is these atoms? Atoms are just tiny, 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 small particles. Okay, Dinet. So these small particles, when they all get together, they make an object,
Like
like a
pixels.
laptop. Exactly, right. So now this atom thing is very wide and very broad. Now, I don't want to go into that in details, because if I go into that in details, you will get lost. Okay, some people who have limited knowledge might get lost. Okay, so now just remember that atom is basically the building block of everything. Without atoms, there can't be anything. So if someone tells you that there is no atom in the universe, that's a lie, right? Because without atoms, nothing can't be there. The earth, the moon, the sun, nothing won't be there without atoms. It's because of these atoms that everything is present. Okay, so even in my human body, if I look at my hand, I'm unable to see atoms. But if I keep a microscope and if I observe, I will see tiny, 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 tiny atoms. And these tiny atoms have got together, they are fused together, and that's how my hand is formed. That's how my face is formed. That's how my bone inside my flesh is formed. Understood? And now I have this purse, a leather purse. This leather purse, black in color. It's solid. I can tap it. Now, if someone will ask, I can't even see any atoms on this. This is just leather. No. Now, if I look at this leather, if I observe it through a microscope, and if I see it, there will be tiny, 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 lots of millions and trillions of atoms. All those atoms together only makes this purse. Understood? So
Yes,
now
sir.
what I'm talking about this gravity is that now if I take this same purse, if I throw it in Jupiter, what's going to happen to this purse? Purse will get crushed. Understood? The purse will get crushed. Nothing else. The purse is like this will get crushed. Okay? But when I throw this purse into the protostar, you know what's going to happen? Now that crushing power is even more greater than Jupiter. Now what is going to happen is not only this purse, the building blocks that made this purse, that atoms which is there in this purse, the tiny, tiny, tiny one, those things also will get crushed. Full and full crush. The entire purse and the atom also will get crushed. Now, do you understand this, guys? If you've got any questions, you can ask. Nivan?
Is there anything smaller than atom?
There is. But just for now, you remember atoms. Okay. Later on in astronomy camp, I'll tell you what it is. Nivan?
Yeah,
Understood?
I understood, sir.
Yes, sir.
Right. Vasadini? Understood?
Yes, sir.
Okay. Who else? Anaya? I can't hear you. Understood. Okay. All right. Okay. So the atom starts getting crushed up. Okay. So these atoms are basically now, if I want to clarify this even more further, if I want to make this even more simpler, it's similar to Lego. Have you all played with Lego?
Yes, sir.
Now Lego, if you break these Lego pieces, they're just tiny, 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 tiny pieces, right? Doesn't make any sense. We don't even know what are these pieces. But if we align these pieces together, if we fix the right pieces together, what happens? We can make this into a nice car, a nice house, a nice helicopter. Like that, we make designs, right? Using Lego. Yes, who asked the question? Never. Yes.
I didn't
Hello?
ask a question.
All right. Okay. So just like that, right? So these Lego pieces are what an atom is. And when you put these Lego pieces together, you build houses, you build new, cars, vehicles, motorcycles, like that. You build different things, right? With Lego puzzles. When we were small, we used to play with them. So these atoms are also similar to that. So these atoms, they have formed together and only they have made various things in the universe. Humans, animals, planets, moons, all of this. Okay. Now this protostar is getting really tense. The gravity is very high. So this gravity is so high now it can even crush the atoms. These tiny people, this tiny things that we call as atoms also can be crushed with this gravity. Now this gravity is extremely high. Not just high, extremely high. Now here you can't even imagine of going and doing your classes, Nishad. Okay, don't go here to do your classes. Okay, go to the moon or Jupiter, that can manage. But protostar, don't even think of going and doing your classes there, because here the gravity is extremely high. Now it will even crush the atoms together. Now what is going to happen is that since this core of this protostar is full of hydrogen atoms. These hydrogen atoms, you have one hydrogen atom, another hydrogen atom. These hydrogen atoms, now what did I tell you? It's small particles, right? Like this here. Basically looks like this. I'll just show it in green color. This is one hydrogen atom, another hydrogen atom, another hydrogen atom, hydrogen atom, hydrogen atom. Like this, you have so many atoms, hydrogen atoms. Now what this gravity is going to do is take two hydrogen atoms and crush it together. Like, like you have this Play-Doh, slime, clay that you play at school. What do? You take two clays and you mix it together, right? When you mix together, can you remove again?
No.
Can you differentiate? No, it becomes one whole thing, right? Similarly, when this gravity will crush these two hydrogen atoms together, and when this crushing takes place, when this fusing takes place, okay, you know the meaning of fusing? You know what fusing means, right?
Yeah.
Yeah. Getting
Right.
together.
Getting together. That's what fusing means. So when this getting together, when this fusing takes place, this is what you call as fusion reaction.
Fusion.
Fusing of atoms is what you call as fusion reaction. Understood? So when this happens, it is not like clapping hands or playing with clay. It's not simple as that. Okay, it's very, 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 very dangerous. When this thing happens, it will release a very tremendous amount of energy. This energy is so powerful that if a fusion, like let's say the fusion that takes place in the sun or the star, in a protostar, if the same fusion takes place in planet Earth, that's it, kudu, completely destroy planet Earth.
Like a bomb.
Okay, yes. Okay, that's how powerful these fusions are, right? So when this fusion takes place, it releases energy, and when energy is released, anything, when an energy is released, it releases heat and light, just like a bomb. Now, Michelle mentioned correctly. Now, when a bomb explodes, does a bomb just explode like that? That's it. No, right? When a bomb explodes, there's a huge
They release
sound coming
energy.
out of it. Energy is getting released. Because of that energy release, what happens? Fire comes out of it. And also, you will see a light, flash of light that you would have seen in movies and all that. What happens when there's an explosion? There's a large fire that is built, and then light also comes out of it. Heat comes out of it, right? Yes, like that. This all this hydrogen in this protostar will start burning. Will start fusing, and they will all start. This fusion reaction keeps happening. Doesn't have an end. Doesn't have a break like us. Today we had a break 20 minutes. Does the star have a break? No,
No.
nothing. Nothing. Star doesn't have a break. Does star have Christmas holidays? Out of the
No.
holidays? Vesak,
No.
Korea? Nothing. No. Right? Every day, 365, 24/7, 365, morning till night, every day it works. Now, what happens if this fusion doesn't take place? Now, our sun is there, right? In the sun, when you go out and when you look in the sky, you can see the sun. Now, the sun is like, you know what? I have been fusing atoms for the past 4.5 billion years. I'm fed up of this. I'm done. Today, I'm not going to fuse. If it stops, what happens?
You'll die.
That's it. That's it. End of everything. Huh?
Yeah.
Everyone will die, right? It will be a very catastrophic thing. Understood?
Yes. Sir.
Okay. Okay. So this proton star basically fusion takes place, and fusion, because of the fusion, this energy is released, and energy is released means light and heat is also released. Okay. So then finally this proton star is what will become into a star. Just like us humans, always, not only in astronomy, whenever you're learning, especially when you're learning science, always you compare scientific terms or scientific theories or scientific stories to real life events. When you compare with real life events, you will understand it even more better. Now, did you understand like certain things over here when I was explaining to you, what did I do? I compared it with real life events, right? So when I compare it with real life events, you are able to understand it much better. So do that. That's a technique. Okay, so that not only in this class, even when you're learning other things in school or any other places, you try doing that. It will help you a lot. Understood. So now again, we'll compare this with real life events, with what we are very familiar with. Okay, so this is basically like when I was born. Okay, so I was born in the year 1999. So when I was born in the year 1999, was I this size?
No.
No, right? So in the hospital, they have this baby cot. So was I sleeping in the baby cot and crying like this, man, like that? This man? No, right? It was a baby, right? It was a small, tiny baby. That tiny baby had grown up, went to school, everything, and now has become into this, become big. The same with Nisha, the same with Dimet, Dasodini, everyone. Everyone was a baby once, and that baby had grown to become a person right now. The same with a star. So before it becomes a star, what do you call it? A protostar. So protostar builds up to become a star. Just like how a baby becomes a man or a man or a lady, this protostar becomes a star.
Or seed becoming a plant.
Exactly, a seed becoming a plant. Yeah, another good example. So protostar only what becomes a star. So our sun, our star, the sun, was actually a protostar once. It was a baby, and now it's not longer. Now it's no longer a baby. Now it's a fully grown star. Our sun is in the middle age. What do you mean by middle age? Now, if you take humans' life expectancy is how much? An average Sri Lankan will live around 8 years. Okay, average Sri Lankan will live around 8 years. So if someone is around 40 or 50 years old, what do you call that kind of a person? Middle-aged man,
Middle
right?
age.
He's not young, he's not old, he's at the middle of his age. So our sun is also a middle-aged star.
Yeah.
Not too young, not going to die, it's in the middle.
Yeah,
But in
last one.
future, the sun will die.
Yes, but when the sun dies, we won't be there.
Yeah.
So we don't have to worry about it, okay? Because it's not going to happen today or tomorrow. It will take billions of years, probably
5 billion
6
years.
billion. Yes, going to take billions of years for that to happen. Now, till this, did you guys understand? Now you can ask questions. Anyone has questions, you all can ask. Like I said, this is an interactive session, so please don't stay quiet. You can ask questions as much as you all want.
Sir,
Yes.
what from what are space rocks made of?
So space rocks are basically, let's say, planets that were destroyed, right? Huge planets that were destroyed. So parts of the planets eventually ends up becoming space rocks. Now imagine this planet Earth. The planet Earth gets destroyed. So these parts of planet Earth, it will become a space rock. So about space rock, there are different types of space rock: meteoroids, asteroids, comets. There are so much. Okay, so these things will be covered in solar system part 2. This is solar system part 1. So solar system part 2 will be next week. So next week we will cover about those space rocks.
Excuse me, sir. I have a question.
Yes.
So the protostar is becoming a star, right? So what is going to happen to the accretion disk?
Yeah, very good. So the particles which is left in the accretion disk. Now in the nebula you have dust particles, gas particles, all those particles. Do you think that when a star is forming that it will take all these particles to form itself? No, right? Now, for example, you are living at home. Now, what happens when we have someone? Okay, let's say there's a boy called Jim. We bring Jim to our house and we keep Jim. We don't give food. We don't give water. What is going to happen? What is going to happen to Jim?
He will die.
He will die, right? He will die. So definitely he needs food and water to survive. So now we give food and water. There's a fridge in his house, there's food, there's all food in the garden, there's a shop where he can go and buy food, everything. Now, do you think that the Jim, this boy called Jim, will eat all the food that is there in the fridge? I will also go to the shop and buy all the food and eat that, and eat all the food in the country, Sri Lanka, all the food in the Sri Lanka, this fellow will eat. Do you think he'll do that, something like that?
No.
He will only eat how much he wants to.
Yeah.
Yeah.
There's a limit.
The amount of food that he needs.
Exactly. The amount of food that he needs. Now, the amount of food that he needs can be different. Now, what it means is, now I am here, right? I will eat a certain amount of food. Now, that certain amount of food, sometimes Nivan can't eat. Nivan will be like, oh my God, I can't eat that. That's too much. I need less. And Mishal will be like, no, it's too less. I need more food. So depending on the person, the amount that they consume varies. So depending on the star, the amount of particles that they consume to become a star also varies. Okay, so that doesn't mean that they consume all the particles that is around them. The particles around them means all the particles in the accretion. So the star doesn't necessarily have to consume all the particles in the accretion disk. So once a protostar becomes a star, there will still be particles left in the accretion disk. These particles, remember in the paint application when I drew, I showed you there are other clumps which are forming in the accretion disk. I showed you, remember?
Yeah.
These clumps in the accretion disk later on become a planet.
Hmm.
Now, once these planets become planets also similar to Jim. These planets also know planet Earth. Planet Earth didn't become a planet Earth like just like that in day one. Planet Earth was also a tiny piece of rock. That tiny piece of rock collided with another rock. That attracted another one. Then another one. Then another one. Kept increasing in size. Gravity also increased. Size also increased. And finally became into a planet. Not only our planet, other planets also. Right? So these all basically we have utilized the particles, the gases that is available in the accretion disk. So does that mean that we have all utilized everything that is there in the accretion disk? No. That's when you have to think about Jim. So Jim didn't eat everything that was there in the house, right? He only ate what he needs. So different planets, they consume differently. Understood? So what was remaining in the accretion disk later on became space rocks, asteroids, meteoroids, comets. So therefore, these asteroids, meteoroids, and comets that you find in the solar system, they are way more older than the planet itself.
Thank you, sir. And I have another question.
Yes.
If our Earth consumes the same amount of energy that the sun consumes, so will our Earth turn into a star?
Yeah. So that actually was about to happen. When you take the 8 planets, there's a planet called Jupiter, right? Jupiter is considered to be the largest planet in our solar system. So Jupiter, they say that Jupiter was also, scientists believe that it was also, forming enough energy, enough matter to become a star. It was actually trying to become a star, but due to some reason, it didn't develop even further, more than that. So it stopped and eventually became a planet. But if it had, if it didn't stop and if it kept going just like the sun, we would have had two stars in our solar system. Star Sun and star Jupiter.
Okay, okay, sir. Thank you.
Yes, Dimit.
Does the moon take the light of the sun and the stars take the light of the sun?
Yeah, so sun has its own light, right? Sun produces its own light due to fusion that I was explaining about. Right? When the fusion happens, it releases a large amount of energy, just like an explosion, just like a bomb explosion, releases a huge amount of energy. So therefore, light is released, and with the light, what do you call heat is also released. Now, this light is traveling throughout the solar system in all directions. So that light is what we are also receiving in planet Earth. The same light we will receive in Mars, in Jupiter, Uranus, Neptune, all the planets in our solar system. Just like the planet, even the moons of the planets. Now, our planet has a moon. Mars has 2 moons. Jupiter has 59 moons. Like that, different planets have different amount of moons. These moons also, they get light from the sun. But the reason why we can see the moon shining or the moon white in color at night is because the light from the sun is knocking onto the surface of the moon, and that light is reflected back into planet Earth. Remember in the start of this class, I showed you this sanitizer bottle and I asked you, why can you see the sanitizer bottle? Remember, did it? And what did I tell you? The reason why you can see the sanitizer bottle is because light is being reflected. Exactly. So the same concept. So here in this my hand, I have the sanitizer bottle. But over there, they are the moon. So the same concept, but I can't take the moon into my hand and show. So that's why I'm showing with the sanitizer bottle. Okay. All right. Okay. Someone has asked the question. So what are reactions when the sun is there? Okay. So when the sun is there, so many things can happen. Okay. Things can go wild. So when you take a solar system, it's just like a family. That you have a family, you have mother, father, and you have children. Imagine without a mother and father, will the children be alive? No, right?
No.
They won't be able to survive for themselves. They won't be able to live. Probably sometimes they might even die, right? Because of starvation and stuff like that. So even the solar system is something like that. If you take the solar system, we know that our planets are orbiting the sun, orbiting this star. That's why we celebrate it, right? December 31st, we burn crackers and we celebrate. What is it? The main reason is because our planet has orbited. A planet has finished one full circle around the sun. So it's not only our planet. All the 8 planets and the dwarf planets, all of them revolve around the sun. Okay. The reason why are they revolving? Why are these planets revolving? Do these planets have a brain like us? No. Does planet Earth think, okay, you know what? I'm just going to keep revolving around the sun? It doesn't work that way, right? So the reason why the planets revolve around the sun is because of the gravitational field of the sun. Now imagine if the sun is gone or the sun disappears, there's no gravitational field to hold these planets, to keep them in orbit. So what happens? Planet Earth will just go here and there, Mars will go here and there, Jupiter will go here and there, and sometimes these planets can collide with each other. That's it. Done. That is one thing. Another thing is, without the sun, plants won't be able to produce food. Since plants won't be able to produce food, plants will die of starvation. Since plants will die of starvation, there
They never
won't be
get
anything to produce oxygen. Since there won't be anything to produce oxygen, humans will die, animals will die. Lastly, everything will die. That is another one. Third thing, this planet is covered by 75% or 76% with water, right? So that means there is more water in planet Earth than land, right? So we know that where there is water, it feels much colder, right? Why is it when it's very sunny, you jump into the swimming pool? Why? Why do you jump into the swimming
cool
pool?
ourselves.
Now I'll give you a good example, right? So when you go to Nuarelia, will you jump into the swimming pool?
No, it's very cold over there. So that's why we
You-
don't jump in the water. Because the
You
water
won't.
will be cold as ice.
Cold as ice. Now when you go to Gaul, you will jump into the swimming pool, right? Because it's hot. Gaul or Colombo, wherever, right? Except Nuarelia. Because water has that tendency, it can cool stuff down. Water has that power. It can cool things down. Understood? So even Sri Lanka, the reason why Sri Lanka is not getting really hot is because we are an island. The water is cooling us down. And the reason why it's not cooling us down so much is because of this sunlight. The sunlight is heating up the water. And that is what is regulating the temperature in this planet. Now imagine the sun disappears. There's no sunlight. It's full darkness. This entire planet will start freezing. Entire planet will start freezing, and there won't be any source of life. Everyone will freeze to death. Yes.
If the sun disappears, the moon's light will also disappear.
Yeah. Moon also won't be visible. We won't be able to see the moon. Sometimes moon might fall onto the planet.
So I have a question.
Yes.
What if there wasn't any sun, but the Earth's temperature was
Sorry?
What if there isn't any sun, but the temperature of Earth stays the same as the sun is there?
It won't. Because space is a very cold area. Generally I'm speaking, when you go to space, it's cold. It's not hot.
I'm just asking, if it happens, what will happen?
It won't happen because there's no source of energy, right? There's nothing which is emitting, light or heat. It's because of the star that we are getting the heat and the light, right? If there's no star, that's it. Now, do we have a star that is as close as the sun? No. Sun is the only star. The closest star is Proxima Centauri. The Proxima Centauri is so far away that you don't even get the light from Proxima Centauri. You don't even get the heat from Proxima Centauri. So it's pretty much useless. Understood?
Yeah.
What happens if a star collide each other?
Star collide with each other. It doesn't happen usually, but if it does happen, It basically doesn't collide. It forms a binary star system. A binary star system is basically when two stars or two or more stars starts revolving each other. Now there's a planet system called Alpha Centauri. So in Alpha Centauri, it's a binary star system. So you have three stars which go around each other.
Excuse me, sir. Another question is,
Yeah.
can a big asteroid consume another asteroid?
No.
Won't consume, but will collide.
Yeah.
Will
But
collide.
now that part is over. That phase is done. Now no more planets are being formed in the solar system. Everything that is to be formed is being formed.
Oh.
Now it's just like a lifestyle of a human, right? So when we were really small, we drink milk. Now, will you feed biryani to someone who is 1 year old, to a child who's 1 year old?
They won't go and they will eventually die.
Exactly, right? Because at that stage, they can't eat food like biryani, burgers, and all that. Only thing that they can is milk. And then when they grow up a bit bigger, then they eat something like, something which is not that hard to eat,
Yeah.
right? Like mashed potatoes. And it's just like that. So at different stages, the world and the surroundings have been in different, environments. I think this was explained by Mason as well, Mr. Mason. When someone asked this question about the dinosaurs, how was the environment before the dinosaurs? Because now the earth is a very calm and pleasant place to live, right? You have the ocean, you have rivers, you have plants, you have mountains, all of that. But at some point, when the earth was formed, when it was a newly formed planet, it was one of the most hostile environment to live. You won't even imagine that we would have lived in this planet like this. Because it was really dangerous. It was super hot. There were volcanic eruptions every time. There was lava all over the surface. That's how dangerous the planet was.
Yeah.
Okay. So now let's move on to the next part. Okay. Formation of the solar system is done. Our star, the sun, right? So how it is now. Don't worry. Everything that is taught in this class is there in your notes. Okay. So all of you guys will receive notes. Even the previous batches also, they also receive notes. Okay. So after every class, you all will receive notes through WhatsApp. Noxilon Institute, they have the notes, so they will send the notes to you guys. Okay, you just have to go through the notes. Okay, so if you forget anything, don't worry. Notes is available. Go through them and learn. And if you have any doubts, you can ask. Understood?
Yes, sir.
Okay. Now, now if you take stars, there are different types of stars. Okay, so many stars. You have red dwarf star. You have red giant, you have red supergiant, you have white dwarf, you have brown dwarf, you have yellow dwarf, you have blue giants. Like this, there are so many types of stars. Now you might be wondering, what are these types? Just like, again, we'll take us humans as an example. You have Indians, Sri Lankans, Malaysians, Indonesians, Australians. Like that, we have different kinds of people, right? Similar to that, there are different types of stars as well. Like these stars, they have different characteristics. They are not the same. Their size varies. The amount of heat that they output changes. The amount of light that they emit changes. Like that, there are categories. Okay, so when we learn about stars, I'll explain that in detail. So like that, our star, the sun, is a yellow dwarf. So if anyone asks you what kind of star is our sun, what's the answer?
Yellow dwarf.
Yellow dwarf. It's a
Dwarf.
yellow dwarf. So what color is our sun?
That means
What color is our sun?
Yellow.
What's the question?
White.
No.
The
Not
phrase
white.
make it yellow.
So not yellow, it's white. Yes.
I got it.
Yes, you are correct. It is white. Okay. Even though it appears to be yellow, our sun is white. But the name is yellow dwarf. That's where people confuse. So people like, why is it yellow dwarf in white color? But it is actually white. The reason why we see it as yellow is because when the light passes through our atmosphere, the light goes through a change which we call as refraction. Okay, so due to refraction, the white color appears to us as yellow.
Yeah.
Now, what is refraction means? Now, rather than explaining that in detail, I'll just give you an answer. Okay, rough idea. Now, sometimes it rains, right? Sometimes it rains heavily, and then suddenly the rain goes away, and then it's full. The sun comes out and it's all sunny and all that. Now, when that happens, have you noticed a rainbow? Have you seen
When
rainbow?
it rains heavily, no.
Rains slightly, no? After it rains and
Slightly.
it's sunny. Yes. After it
Sunny.
rains and then the sun comes out and there's no more rain, then you will see that there's a rainbow. Now, this rainbow is formed because guys, actually now that the rain is over, it doesn't mean that there is no, water in the sky. It doesn't mean that there's actually water particles in the sky that we can't see. Now, when the light comes and hits this water particle, it gives out different colors. Vibgeo, which is basically the rainbow colors: violet, indigo, blue, green, yellow, orange, red. So that phenomena is what we call as refraction. Another good example is in the fish tank. You guys, when you put your hand inside the fish tank, sometimes you might see the fish, like, it's coming closer to you. But actually the fish is not closer, it's somewhere else. But you might see it as it's coming closer. Sometimes, let's say you have a glass, okay, filled with water. You're putting a straw into this glass. And when you look from outside, it's like the straw has broken. Have you seen it? The straw doesn't look straight. It looks like the straw has broken into two parts. All of this is because of a phenomena called refraction. The same refraction is responsible to make the sun appear yellow to us. But if you leave the planet Earth, if you escape the atmosphere of planet Earth, and if you observe the sun, you will see it is white in color. Okay, guys, clear?
Yeah.
Yes.
I'm clear.
All right. Okay. So another one I told is the sun will become will die, it will cease to exist, it will become a red giant approximately in another 6 billion years.
Yeah.
Okay, right. All right. Okay. Next is what we call as another one important thing.
What's the thing, sir?
Yes, another very important thing. Now this part what we covered, do you have any doubts?
No.
No doubts. Okay, perfect, super. So next what we'll be learning about is something called the Goldilocks zone or the habitable zone. Now, do you all have any idea about what this habitable zone or Goldilocks zone means?
There's a story named Goldilocks.
What? Cartoon?
No, there's a story.
Story, yes. About the bear, right? Goldilocks bear or something. Right. So now before we go into Goldilocks zone, there's few photos that I want to show you. The things that we talked about. Okay, so hold on. Earlier we discussed about the protostar, right? Protostar. This is what a protostar. This is how a protostar looks like. You see this middle part, this middle region.
Yeah.
Slowly. This middle region is what eventually becomes the protostar, and that protostar becomes a star. And this disk around it is what we call as an accretion disk. And the planet starts forming in this accretion disk. Okay, this is a protostar, and this is an accretion disk around the protostar. Understood? This protostar later on becomes a star. And in this accretion disk, there are other small clumps which takes place, and those clumps are not as powerful as the clumps which formed in order to make the protostar. So therefore, these clumps end up becoming planets. Understood? Right. So
I
these are
understand.
protostars basically. Next one is basically the yellow dwarf star. These are yellow dwarf stars looks like. Can you see? So our sun is also a part of this yellow dwarf star. Understood? Remember another thing that I talked about where a star is formed, the star nursery. What do you call it?
Hmm?
What do you
Star
call it?
nursery is a place where stars are born
What is
and
the
the
name for
stars
it?
stay. What is the name?
Yes.
Star nursery.
Yes. I said it's a huge, giant cloud. The stars are
Nebula.
formed.
Wait,
Yes. Yes. Well done. It's called a nebula. So how does a nebula look? This is how nebulas look. A very nice, beautiful to see. So these regions are where stars are formed. So these are nothing but clouds, giant clouds
hmm.
in space. Clouds filled with dust particles, gases, and all that. See, these are different types of nebula. Not this nebula. This is Avengers nebula. This one, I'm talking about these nebula. Right. So now that part is covered. Now I'm talking about Goldilocks zone or the habitable zone. Now there is actually a story about Goldilocks, the bear, right? Demet also said this. Now this is not about that bear. This is a different thing that we are talking about in astronomy. What is this Goldilocks zone or the habitable zone? Both are the same. They either call it as the Goldilocks zone or they call it as the habitable zone.
Wait, Goldilocks zone is the outside of Earth.
Yes.
No,
So
yeah.
what does it mean? Yes. So what does it mean to be habitable? What is the meaning of habitable?
We can
Like
live.
living beings can live.
Yes, some place where it's something can live, right? That's what basically habitable means.
Goldilocks
Yes.
zone is near Earth, right?
Sorry?
So that means Goldilocks zone is Earth.
It's the place where the earth
Yeah,
is.
hold on. Yeah, so basically, so habitable zone, right? So word habitable, you guys know it, right? We all know English, so we know. Habitable means some place where we live. Something lives, some organism lives, right? Doesn't have to be humans, can be animals, can be plants, can be anything. So the habitable zone or the Goldilocks zone is not something that is only common to our solar system. It is also available in other solar systems as well. Understood?
Yeah.
So remember I told you that there are other stars as well in our Milky Way galaxies. So around those stars also you have planets, right? So those are also basically star systems or solar systems, just like our system. Understood? So in our system, our solar system also there is a Goldilocks zone. There's a habitable zone. In other solar systems also there's a habitable zone. There's a
Wait,
Goldilocks
then
zone.
why don't we live
Now,
there?
yeah, yes, that's why I'm coming to that. So now the question is, what is this habitable zone? What is very special about this, right? So that is the question. Now, for example, we have different places in our in our city, right? Some place we call it as the police station. Some place we call it as the hospital. Some place we call it as the school. Now, when you go to a school, can you perform an operation in the school?
That would be silly and it's crazy.
Exactly, right? So in order to perform operation, you have to go to the hospital. In order to study, you have to go to the school. So just like that, in the solar system, in any star system, there are different regions. And one of that region is what we call as the habitable zone, or in other words, the Goldilocks zone. So this zone, the speciality of this zone is that it is able to sustain life. Now, why is this zone able to sustain life? Now, this is a region in the solar system, okay, which is not closer to the star or not too far away from the star. Okay, sometimes when we are drinking water, we drink cold water directly from the fridge. And then what
Yeah.
happens? We are unable to drink the water, right? We are like, okay, brain freeze, brain freeze, brain freeze. We are unable to drink, so cold. Then sometimes we boil water and we start drinking it. Then what happens? We burn our tongue. Then what do? The water that
Even,
everyone can drink is what? Lukewarm water, right? Neither cold,
yeah,
no hot.
neither hot.
So yes, so the habitable zone is a zone similar to that. So the planet Earth, so the habitable zone of our solar system is where the Earth and Mars is located.
Yeah.
So if you take Mars and Earth is neither closer to the sun nor far away from the sun. It's in the right position. It doesn't get too hot or it doesn't get too cold. Now, if you take for an example, you have Mercury, Venus. Now, when you take Mercury and Venus, they are very closer to the sun, therefore, they are extremely hot. When you take Jupiter, Saturn, Uranus, Neptune, they are very, very cold. But when you take Mars and Earth, they are neither hot, neither cold. Now, why am I focusing on neither hot and neither cold? The reason for that is because according to humans, according to the biology that we humans know of, every single organism that we have documented need water to survive. Okay, this was also explained by Mr. Mason. Remember when he was talking about these dinosaurs and stuff, he told you all that water was the source of creation. It's because of water that life came into existence. Without water, life wouldn't have come into existence. Understood? So now I'll give you all a small experiment. Now you fill water into into a cup or into a glass. You fill water and you keep it in the fridge, in the freezer, in the fridge. You have a freezer, a portion where you can freeze stuff in the fridge. You keep it in the freezer. What is going to happen to the water?
The water will freeze eventually and turn into ice.
Ice. Now, ice is liquid or solid? What is ice?
It's solid.
It's solid. Now, the same glass of water, instead of putting it in the freezer, you keep it on top of a cooker. What's going to happen?
It's going to turn into steam and it's going to turn to the water shape.
Water vapor, right? Steam. So steam or water vapor is what basically? Gas. Gaseous state of water, right? Ice is solid state of water. Gaseous state of water is what you call as water vapor. Solid state of water is what you call as ice. So water, if there is water in Uranus, Neptune, in those planets, it will probably be ice in nature. If there is water in Mercury and Venus, they will probably be in gaseous state. But since Earth is located in the habitable zone and it's neither hot nor cold, water can exist in liquid state. Now, the fun fact is that when water exists in liquid state, that's when miracles starts happening. That's when life starts forming. That's when life starts thriving. That's when organisms have a chance to live. When water is in liquid form. When water is not in liquid form, it's very hard for any living being to live. Understood? Right? So planets, so now you would have seen that sometimes scientists say, okay, we have found a planet similar to Earth. Have you heard news like that? I think you would have, right? So, hold on. One second, Yasodhi. Okay. All right. So when scientists find those kind of planets which are similar to planet Earth, what they basically, so what we'll finish it right now, okay, from this Goldilocks zone. Class is not yet over. There's few more lessons to be covered, right, under today's topic. But since time is up, we'll finish it from here, but the remaining part will be covered next week's channel. Understood, guys? Everyone cool with it?
Yes, sir.
Okay, so now I'll finish it with the Goldilocks zone because I don't want to stop it halfway, then you all will be confused. So I'll finish with Goldilocks zone and we can end the class. Okay, right. So when scientists are finding for other planets similar to planet Earth in different solar systems, they find planets which are not too closer to the sun, not too closer to the star, or not too far away from the star. They look at only those kind of planets. And when they find those kind of planets, they announce to us, general public, right, we have found planets which are similar to planet Earth. So therefore, one day, hopefully, when we are technologically advanced, we may go to those planets and live. Because there is liquid water. And sometimes they even say, since these planets have liquid water, there might be organisms that are already living in those planets, which
So I
we
have a
call as
question.
aliens. Yes. Yes,
Is
Nima.
there an actual planet called Earth 2.0?
Yes, yes. There is. There is. That Earth 2.0 planet is a bit bigger than planet Earth and has liquid water in it. So scientists believe that, it could sustain life. And sometimes it might already have life, but we can't say for sure because we don't have enough, technological power to determine if there is life living on the planet or not. But later on, hopefully in future, we might be able to find that as well. But if we do find that out, then that last Saturday we watched about UFO and extraterrestrial, that entire topic will be proven to be true.
Yeah. I
Okay.
understand.
Okay, so now Goldilocks zone is explained, right? So we will share the notes with you all. Go through the notes. Next week, Saturday, join at 3 p.m. We'll finish at 6 p.m. Today, the reason why it got a bit delay is because we had the introduction because of the new students like Anaya, Dimet, Yasodini, because Mishal joined us last class. So no issues with Mishal, but other students, they didn't have any idea, right? So that's why we had to keep this introduction. So that's why it got a bit late, but don't worry. Next class, when we learn about solar system part 2, I will include whatever we missed in this class. Okay, we have few topics that I didn't cover this class. So I will cover that up in next class session. Okay, so you guys don't have to worry. So now you all can leave, but before you all leave, remember I told you all have 3 tasks to do. So task number 1 is you have to record a video of whatever that you learned in today's lesson. Right? So we learned so many topics, right? About the Goldilocks zone, how the star was formed, the accretion days, or the protostar. Whatever topic that you like, you select a topic, you get the facts about it, and you record a video of not more than 2 minutes, less than 2 minutes.
So what about
Okay.
the temperature of star and the differences of stars? And those
Different
topics?
types of stars, you can, but don't do it now because this topic is not about stars, right? It's about the solar system. So something related to the solar system would be better. Understood. Now I'll show you a video of one of my students from the first batch. He is explaining the what do you call the Goldilocks zone. Now watch that video and then you will get the idea. So like this, your videos also will be posted. So if it's small, only then people will watch it interestingly, right? Because if it's too big, people will not What's it interesting? His name is Binal. Okay, Binal Pereira. He will explain about the Goldilocks zone.
The location of the Earth. The Earth is located in the Goldilocks zone. The Goldilocks zone only sustains life. If another planet takes the place of the Earth, it will sustain life. Mars has water, but it's not liquid water, so it can't sustain life. Water is a thing what we need for life to sustain. Thank you.
Understood, guys? So that's how your videos have to be. Short and sweet, to the point. Understood?
Yeah.
Okay, guys. So you can go through these videos as well, get an idea, but don't do the exact same thing that these students also do. So then if you do that, then it's no point, right? So you all have to make sure that your work is original. It's not copied or anything. Understood?
Understand.
So that is the first task. Second task is what? You have to draw your favorite planet. You have 8 planets now. So draw your favorite planet.
Yeah.
Okay.
Okay.
So when you draw your favorite planet, make sure that you draw it properly, because now when you look at planet Jupiter, it has like a coffee color, like coffee brown.
Wait, we have to draw it, and we have to only draw it and have to show it in that thing where we talk about the planets.
No, that's a different task. The video recording, where you select a certain topic and you talk about it for less than 2 minutes. And once that is done, you record it and you send it to us in WhatsApp. That's it. Second topic is you take a piece of paper. So solar system part 1, this is the work that you all have to do. You take a piece of paper, white color piece of paper, and then you select a planet from the solar system, any planet that you like, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. Select any one that you like and you draw it properly, nicely. Try to make it look realistic as possible. Okay, now for example, that's what I'm saying. So planet Jupiter has this coffee brown color, like light brown and dark brown color, and it has a red giant spot in the middle. So you have to draw that the same way. Now, for example, you can't say planet Jupiter and then draw a planet and color it in purple color. Understood? So that doesn't make sense, right? Planet Jupiter is not purple color, so it's light blue and dark brown in color, right? Light brown and dark brown in color, mixture of both, like coffee brown. So that's what you guys have to do. And also don't worry, I will send you all a notice as well. So in the notice, you will have all the tasks that you all have to do. So even if you
have to write a note in a book.
Notes, you can write a note in your book. You can maintain your note in your own notes. I highly recommend it, but it's not mandatory. But anyways, at the end of every class, you will receive notes from us. So today's lessons, you will receive a note after this class. Okay, understood? Perfect.
Yeah.
Anaya, all good?
Yes, sir, understood.
Dimet? Already sent. Okay, notes have been sent. Dimet? Hello, Dimet. Hello. Dimet, are you there? Dimet is not there. Okay, don't worry. So those who have left or who are not there, I will send the task list also, okay, to WhatsApp. Notes is already sent to you all in WhatsApp. So after class, go and see the notes. Okay, I will send you all the tasks. All right, guys, then that's it, today's lesson. So I hope you all enjoyed it. See you all next week on Saturday, 3 p.m. Have a nice
Bye,
day.
sir.
Good evening, good night. God bless you. Bye. See you.